Check. Cool. Check one, two. Check, 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 check. Yeah.
All right, awesome. Thank
Don't
you.
scream. I have to set the levels upstairs, but you can go ahead and start.
Okay. All right, awesome. Thank you for your patience, folks. So my name is Alicia Cozine. I'm with Data Curation Experts, and I'm going to give a very brief overview of some concerns around monitoring in Hydra. So the first most basic question, why would you want to monitor your Hydra machines? Let's face it, stuff will go wrong. When it goes wrong, you want to be the first to know. You do not want to hear it from your end users, and you do not want it published on the front page of the Washington Post. For those of you who are looking at this picture and going, what is she thinking? That is Bob Woodward of Watergate fame. So there are lots of options for monitoring. Some monitoring services are paid. Some are free and open source. I picked 5 popular ones at random. There are several dozen available. So if you have budget, paid service might be the best fit for your organization. If you have more in-house expertise and less money, an open source approach might be better. If you're at a large institution and you have a central IT department, the good news is they probably already have something set up. The bad news is then you're going to need to talk to them about getting your Hydra servers added to that system. Here's an example. This is DCE's Nagios setup. It is free and open source, and it's flexible, fairly complex. It works well for us. Basic monitoring of a Hydra server is the same as for any Linux server. You want to make sure that the server is up, the first and foremost. You want to make sure it has plenty of resources, memory, disk space, processing power for whatever load you're putting on it. You want to make sure that its network connections are up, and you want to make sure that it is not being overwhelmed by a large number of either users or processes, which might indicate a problem with the code or a security breach. A few things you will definitely want to monitor specifically for your Hydra servers, your Fedora, or if you're not using Fedora, the repository software of your choice, your Solr, or again, indexing system of your choice, and your background workers, rescue, or other. One of the highest maintenance pieces of monitoring is notification. It's obviously no good to anybody if your monitoring system knows there's a problem and it's sending email to the wrong person, or it's sending email when you wanted SMS, or in some other way it is failing to notify the correct person in a timely fashion. One of the most common problems is you have turnover and suddenly you're sending email to somebody who's no longer on your team. So this is especially important if you are running it on a central IT system. Make sure that all that contact information gets maintained. We recommend you test your monitoring, not on your production systems, but on a staging server, you might want to take the whole server down, see what happens, see if or take down a single service, do the same test. You can do this as a planned outage. That's obviously kinder to your operations people. Or you can go full-on chaos monkey and start taking stuff down at random times. Finally, at DCE, we like to approach monitoring as the equivalent of testing. So we have test coverage for your code. You have monitoring coverage for your systems. If you have a problem, when you have a problem, first off, fix the system that's gone down or the service that has gone down, and then go back and look at the policies and procedures that got you there, update those so you prevent a recurrence, and then finally add a test to your monitoring system so you prevent regression. An example of this, we had a system where the rescue workers were running, but they were running on stale code. Once I figured that out, I fixed the rescue pool so that the developers were able to go on with what they were doing. And then I traced the problem to our Capistrano deploy, which wasn't correctly restarting. I fixed that, and I felt really proud, and I was glad. And then I thought, yeah, but it might happen again, so I put a test in our monitoring system. So that's all I have today. Thank you very much. Yes, good luck.
Sort of. It's taking a while to catch up.
Use the black one instead. You can plug into this one instead.
All right, okay.
Just this here.
Yep.
Do you have your own Mac adapter?
I do.
You do?
I didn't know. Oh, there's the VGA.
Yeah, I'll try that.
Too much choice.
Yes.
Not getting anything there. It's a bit strange.
Okay, we'll just try the HDMI one. Yeah, it's not
Mhm.
going to apparently take that.
Not sure if I got. Uh-huh.
Is that okay?
Yep, that's okay. Right. Okay, good morning then. Thank you very much. So what I wanted to talk to you about today is an initiative taking place in the UK for awareness raising around the idea of development of shared service for research data that JISC is taking part in. I'm a part of the advisory group for the JISC on this project, although I'm not directly involved in it, but it does involve Hydra, hence the link. The idea of this shared service is that we want researchers not to think too much about research data management, so be able to see their data, work with their data, but not be too fussed about or bothered about what the infrastructure is behind the scenes. Provide researchers with intuitive, easy functionality to publish, archive, and preserve their research outputs. And key to it is providing a suite of interoperable systems that provide different parts of the functionality and, within the research data workflow and life cycle. Within the UK, we have a number of drivers behind this. One of them is to do with RDM policy compliance, another one's about sector efficiencies. We're keen to maintain the integrity of research, which is one of the bases for why we want to manage research data and share it more openly as well. But also recognizing that there are big gaps. Lots of people have been looking at research data management systems for a while, and there's no obvious solution out there on the market per se that does everything we need. Therefore, the idea of doing a shared service that brings together different components, different tools, which seeks to try and plug that gap. And it's about getting people up and running with research data management in a way that they would like to be, given that there's a certain amount of frustration about needing to do this, wanting to do this, but not having the wherewithal and tools to do it. Some of the feedback from the pilots, the institutions, are that they want easy-to-use, cost-effective functionality. They want robust data storage. They want a metadata profile that everyone can use for interoperability. And they want to be able to meet their compliance requirements. So it's fairly clear messages. In terms of what the system's intended to do, it's intended to have these different layers and address all of them. From the UI at the top there through to the middle layer with the APIs integrating different systems, different ways in which you can store the data, and then also adding a preservation layer and preservation functionality to ensure that if we are being asked to keep data for 10 years or more, then we are in a position to be able to deliver it back to people at the end of that time. Key to the way that the JISC is looking to make this work is to integrate systems in a way that enables different components to be added to the architecture overall, but then have a way of then interoperating with other components. And so they want to, in a sense, they're recognizing that the left-hand diagram is how we're doing things at the moment, is linking up things in an individual way, and try and sort of address that by providing a sort of backbone, messaging backbone, that will enable different components to be added to the overall service, both now and over time. In terms of taking this forward, they put out earlier this year a series of lots that companies could bid for, and the three main ones revolve around research data repositories, around research data preservation platforms, and around research data reporting. And you can see that a number of different companies have responded to those and been added to the roster of potential suppliers to the shared data service, of which, under research data repositories, it's very pleasing to see that Hydra is represented through a consultancy involving a company called Zero in the UK, but also Cottage Labs, who are present here at Hydra Connect. There are other lots as well. One is to do with integrations, and there's a number of bidders to that one. One of them is to do with data exchange, to facilitate the movement of research data between the different components. One of them is to do with integration with what we call CRIS systems, current research information systems, which are proving to be very popular and very common in the UK environment now. One of them to do with preservation tools development, which is of building on and extending the preservation platform. And one of them to do with user experience. So there'll be a number of different ways in which these are put together. And the idea being is that all these suppliers put forward what they can provide. Then the pilot institutions will select which ones they'd like to work for, and then JISC will work with them in order to make sure those different components can interoperate in the way that is most appropriate. These are the pilot institutions. It's a wide range of different bodies in the UK. Key from a Hydra point of view is that two of those, Lancaster and York, are both Hydra adopters, and I'll be very keen to be working with Hydra on how they can use that to provide a research data management shared service that other people may then be able to tap into as well. In terms of the timeline, so there's all kicked off last year with the initial tenders, the different lots. And we're going to work through, we're currently in development phase, alpha and beta, going into next year, with the idea being is that from next summer they'll be looking at business models and business cases for how they can roll out the results of these pilots from 2018 onwards. Thank you.
Maybe too fast. I might be too fast. Yay. All right. So I just want to talk really briefly about Cavendish, which is a project I've been working on when I'm maybe should have been working on other projects that you already use. It's an implementation of Fedora that is built. Well, it's an implementation of a future Fedora that is built on BlazeGraph. It doesn't use BlazeGraph as an index. It actually uses BlazeGraph as the data store. So what does it do? Right now, as it exists, which it does, it supports the LDP RDF source and all 3 container interaction model specifications. It implements the Fedora draft spec for versioning, which mashes LDP and Memento together. It runs the LDP test suite really quickly. And it runs Esme's magic real-world performance test stress rig really quickly. Really quickly, right, Trey? Right? Quickly? It's really fast. What's it going to do? It's going to do the rest of LDP. It's going to have a non-RDF source and the descriptions of them and the Fedora draft spec as they're released. That is to say, as we get closer to finalizing the fixity spec, it'll be implemented over here. And it'll have a Sparkle endpoint because BlazeGraph has a Sparkle endpoint, and the only reason it doesn't have that Sparkle endpoint right now is because I took it out to get the embedded Jetty to run faster. So I'll be putting it back in promptly. Why did I do this? Fedora needs additional implementations. You can't just have the one Fedora and then argue that you are building this community-oriented specification. You're going to fall victim to a number of different idiosyncrasies of your own thought, and then your audience will be made to suffer for it. There's also a demonstrated need for really lightweight Fedora configurations that also have persistent storage. So there is another Fedora. There's Derby, but Derby mostly runs in memory, and eventually somebody's going to want to store something and not want a lot of the other business that's attached to the JCR-backed Fedora. Triple store-backed LDP implementations are really, really fast at some modeling approaches. They're not going to be a panacea. There's going to be some things they're slower at. We could have a longer academic conversation about how everything, there's performance considerations to all backends. So it won't fix everything, but it will fix a lot of things. And frankly, it wasn't a tremendous amount of work because the LDP specification obviously is closely aligned to RDF and linked data, and because I love you all. I especially love Princeton being a Fedora partner. So what am I going to do with it? It depends. I need this as a product because I am the author of a lot of these Fedora specifications, and I need something to push against that is not Fedora on JCR to make sure I understand whether we're specifying something that works on mode shape or something that actually is reasonable as a repository specification. But outside that, it depends on whether anybody else wants to do something with it. So I have use cases I can imagine for this at my own place of work, but I would be reluctant to go forward with them if I felt like I was doing that alone. So I am open and receptive to feedback of people saying, yes, I would like this. You don't even have to say you'll work with me on it. You just have to say you'll use it, and I'll reconsider it. Why did I call it Cavendish? Margaret Cavendish is a 17th century aristocrat, poet, a scientist, although she was kicked out of the British Academy because she was a lady, basically. She showed up for one meeting. They said that she had an unpleasant disposition and antic dress, and she was barred from the academy. And I think it was only rescinded, posthumously barred. They took that off the books 50 years ago. So anyway, but also, so built on BlazeGraph, she wrote this thing called The Blazing World, which a lot of people think of as a seminal work of science fiction before science fiction existed. And there's clearly the naming correspondence with BlazeGraph, but also some stuff in the way that she writes about it that I think reflects some things that I would like to see about alternative implementations of well-composed specifications and a certain consideration for multiplicity. So if you're interested in any of that, if you want to follow up with me, there's a Google group, very active. When I am sending a message to my other email accounts, you can email me directly, or you can get at me on Twitter. Thanks.
5 minutes, and I will be sitting with my stopwatch and sending you signals for 2, 1, and finished. And when finished really means finished, so if I say 1, that's when you have to think of rounding off to keep it going really smoothly. So if you have any questions on the way, take them down. We're probably not going to have any time for questions, but then you can refer to the speakers afterwards in the break. So introducing now the first speaker, David Cliff, who will be giving this talk, Making XML Schema Validation More Reliable. Welcome, David.
Hello, my name is David Cliff. I'm with Northeastern University, and I wanted to talk a little bit about schema validation, which I realize now, like, my title is very boring compared to some of the great ones I've seen already, but it has been very important to us. So a couple months ago, we noticed that a portion of our system started to time out pretty regularly, and then at one particular event, it timed out for a whole day. And my repository manager forwarded me this email from the Code for Lib mailing list, which was unfortunate to read. Basically, the Library of Congress had been under attack, and we were using the schema that was on their website for our validation, and that process started to stop. And as a result, they sent out this email saying that they were going to start filtering requests. And I don't blame them. Programmatic requests to materials can sometimes be very hard to determine whether or not they're valid or not, and whether or not they're an attack or a denial of service thing. But what followed was our solution to a problem that probably should have been a little bit easier if Nokogiri had the capacity. So the standard way to deal with needing to mirror schema validation is using the XML catalog. Unfortunately, and I'm more than happy to be proven wrong with this, Nokogiri doesn't allow for it. It will, you can change the first one, but schema validation can be nested. So I know that mods 3.5 has 2 import statements, and that's where that would fail. So without the capacity to use a standard XML catalog, we had to do a slightly different thing. We built a gem. It's called Kataba. Basically, it does for Nokogiri what an XML catalog would do for Oxygen or anything else. It downloads the schema to be used offline, which is really useful for testing, for RSpec, and it's also kind of being nice to Library of Congress too. I noticed a lot of posters yesterday where people are now doing batch ingest into Hydra. We do schema validation on every one of those, so we've started doing thousands of schema validations a day, and we were doing it against Library of Congress, and now with Kataba, it's just on our offline stored things. So even if you haven't noticed that it's broken in your system, which I imagine you will in the future because they're going to start filtering, using Kataba will be nicer to the bandwidth of Library of Congress, and I think that's probably a good thing. So if you have any questions about it and the documentation on GitHub or RubyGems doesn't help you with it, then I'm happy to answer any questions, so you can come find me. And yeah, hopefully it's of use to some other people in the Hydra community. Thanks.
Thank you very much for that. Moving on, everything seems to be changed now. Well, the sequence just changed on my page, but let's move on to Stephen Ng, who will now tell us everything about Ruby and Rails resources for new and not so new Hydra developers. Please, Stephen.
All right, I'm Stephen Ng from Temple University, and I'm going to be talking about Ruby and Rails resources. This is going to be a lightning talk. done in the style of Ignite, 15 seconds per slide, so I have 20 slides to present to you. And it's not changing. Oh, there we go. Warning, this talk is biased. It comes from my point of view. So I'll do what I can, but you try to do this in 5 minutes. And the link will be up here for the next 30 seconds. Okay, so where did this all start? It started with this YouTube video that DHH, or David Heinemeier Hansson, posted about how to create a blog in 15 minutes. And everyone caught on to this, and they were just so amazed. And I can do this. However, you're now presented with this, and you've been thrown into the deep end, and you're going, well, that's nice. You can create a blog, but I need to create a Hydra stack. What am I going to do? I don't even know that much about Ruby or Rails. Well, the thing you can do is go to online videos such as Railscast. Now, Railscast ran for a few years, and then it shut down. Ryan Bates decided he needed to do something else. However, since it started off as a free premium model, those videos are now available on YouTube. There's also currently available Ruby Tapas with Avdi Grimm, who's an expert in Ruby and Rails. This is pretty much a pay model, 2 levels of subscription that you can go with, but there's a lot of good information there. There are also major Rails conferences. These are a bit expensive, and they're in different parts of the country every year, but as you can see, Rails Conf is coming up soon, and it's in Cincinnati, so I know our friends from UC would like to go to that, right? Any other conferences? They're available on ruby.con, rubyconferences.org. So there are regional conferences such as Gotham Ruby Conference and Ruby Nation, and other ones around the world and around the country. If you can't go to those, you can always try videos of those conferences. Confreaks does a great job of covering all of the technical open source conferences, as many as they can get their hands on. They will stream live or delayed on YouTube. Different Ruby sites, such as Ruby Weekly, which has the latest Ruby news, the latest stuff from the official Ruby weblog. Ruby Facets, there used to be a site called, or a podcast called Ruby 5. They don't exist anymore. Now it's Ruby Facets. There's also the option of local meetups. If you live in a major city, you can just go on to Meetup and type in Ruby or Ruby on Rails in your Meetup search, and chances are you'll find a local Ruby meetup. And some of those organizations even post videos. I used to produce videos for Los Angeles Ruby. This is one of our most popular videos on test-driven development by Evan Dorn. So just search YouTube. Now, something that started recently was the Hydra Code Club, which lets us have a chance to read code together, help to improve our Ruby skills and our Rails skills, and also to dig into how Hydra works. The origin started last year with Anna Headley, who posted this message to the Hydra Tech group, and within 2 weeks, we had our first hangout, and we studied Hydra Editor. And here's a link to that to that posting. Now, the format is you sign up for something you'd like to cover, and you're going to be the tour guide on this. Then you're going to start promptly when you have your scheduled hangout. You're going to open up the GitHub page, and you're just going to walk through the code. Anyone can be a tour guide. You don't have to be an expert. All you got to do is drive the bus, as it were. In this case, it's the screencast. And if anyone has any questions, you don't have to know the answer. Someone else can know the answer, or they can look for it on the web. Some considerations: don't rush like I'm doing right now. People are trying to read code. I want to keep pushing things forward, but it takes time to absorb code. Ask questions. Someone online might know. And if you answer a question, please consider the Hydra Connect Code of Conduct. We do it in a small group. We're in a hangout. We're limited to 10 people. There's a good dynamic in small groups, and we meet regularly. Finally, we'd like you to start your own Hydra Code Club. How are you going to find these people? You can post something to the Slack channel or to the mailing list, or your people you've been meeting around here. And on top of that, share what you know, and what can I say? Go explore. These are online already on the Hydra Connect 2016 webpage.
Thank you very much, Stephen, for this very timely presentation. lots of stuff to dive into. Moving on and welcoming our next speaker, Chris Bartos, who will tell us about how to integrate handle system with Sofia. Welcome, Chris.
Thank you. Hello. My name is Chris Bartos. I'm with Ohio State University, and I'm going to teach you how to integrate handles with Sofia 7.0. What is a handle? A handle is a representation that maps to a URL. So the basic parts is the handle prefix, which maps to a handle server, and a handle itself, which maps to the URL. So if I wanted to go to htl.handle.net, 1811.1, and OSU 123, what it would do is handle.net would say, hey, OSU, you have this handle. Is OSU 123 mapped to anything in particular? And OSU proxies would say, sure, so redirect to that URL. It's really quick, which I guess is the point. You don't want a handle that takes forever to go to your URL. And if you want to read more about the protocol, it's request for comments 3652. So what does this get me? The handle will always, the URL should always be the same. It should never point to something else. Otherwise, you're going to have really angry librarians. So let's look at some code. How you would do this is you might add some code to a callback. In this case, we do after update metadata, and I'll tell you a little bit more about why we do that. And we'll look into the handle service. At initialization of the handle service, we get some variables. Whether we want to mint handles, sometimes we don't. Production, we definitely would, but in development, probably not. Prefix would be something like your handle prefix. In our case, it's 1811 or 1811.1. Index is usually 300. And then you have some administration stuff that is obviously not something that I should tell you about. And then you mint your handles. All the code above is taken directly from the gem that we use. It's the handle system gem. And we basically just create it on our handle server and then add it to our generic work. Save it. Some other stuff you might need to know is you do need the handle server tools. You can download those from handle.net. You'll need external-facing ports open on UDP, HTTP, and TCP. The reason why is because it will loop through each protocol and see if anything is open. And if something isn't open for the first protocol, then it has to go to the next one, which can take a lot longer to do. And our code will only create a handle if it's a publicly available generic work, because if it's not publicly available, why mint a handle? This is important for things like migrating from DSpace to Hydra or Sofia. If you ever want to keep those handles, you can do that. And I'd be really interested to know if this is just a one-off solution or if there's a need for this out there, because this could be something that could definitely be gemified really easily. So thank you.
Thank you very much, Chris, for this talk. Then we have our final speaker in this first block is Corey Hinshaw, who will speak on developing a Hydra application with Docker. Welcome, Corey.
Okay, so hi, my name's Corey Hinshaw. I'm also from The Ohio State University. And we've recently been doing quite a bit of application development around a Hydra application, Sofia in particular, but this could apply to essentially any project that you're working on. And the reason this came up in our group is that the challenge is when working with Hydra, you might think the picture looks like this, or at least that's the story that gets told, but really the picture looks much more like this, right? There's a lot of stuff that goes into a Hydra, or really any modern web application, right? You have Solr indexing, you've got the Fedora backing data store, you've probably got to be managing Tomcat, Java, or some other servlet container behind things, and if you're a Rails shop, that might not be your expertise. You might have image caching servers, VMs running conversion tasks, things like that. And all of this stuff is, of course, manageable and doable, but it really is difficult to manage all of these dependencies, particularly in a local development environment. So Docker can maybe be one stab at helping with this. So just a really brief overview of Docker. Docker is essentially a very lightweight container runtime. And I've only got like 2 minutes, so I'm going to gloss over some of the technical details, but you can really think of it like a bare bones virtual machine. So if you're familiar with VMs or Vagrant, it's a similar but different concept. It includes a package of utilities for creating and managing these Docker containers, and it's also a community hub of shared Docker images, similar to Ruby gems or NPM, anything like that. You can go to docker.com for more info. So why would this help us? The big thing is it reduces onboarding time for new developers. You don't have to spend days setting up your local development environment, getting ImageMagick installed, building other dependencies. You can stop managing those local dependencies. Your runtime environment, or at least your development runtime environment, is sort of somewhat self-documenting because it's contained in your code base. And you have potential parity between your CI and your production if you use Docker to deploy to those environments. The cons, of course, is it's just one more technology to add to this stack. It's one more piece of that big picture we looked at earlier. Docker images are fairly large, being virtual machine images, and they are somewhat network intensive to download at first. And standard Rails commands start to look a little different. So let's take a look at a little bit of code. This is the Docker file for it's a creatively named Docker file for your potential curation concerns Hydra application. So essentially at the top there, we are installing some necessary dependencies and packages. We are installing fits to do image characterization. And then we're doing some magic to mount our project within the Docker image so we can work on it, similar to Vagrant. And then Docker has this utility for the orchestration of external containers called Docker Compose, and that's set up in this Docker Compose YAML file. So you can kind of take a look at this and get the idea that we're setting up a database image based on Postgres, we're setting up a Redis server, we're setting up Fedora with an FC repo image, and we're setting up Solr as well, and then an actual Docker container to run our application. So what this lets you do is take all of the dependency management stuff that you had to do to get applications set up before, and now you set up your application by cloning it, running Docker Compose build and Docker Compose up. And that gets you something like this. And for the Rails folks in here, you'll notice this last line. It looks like we've got a Rails server running. And we've got our sort of curation concerns application running available on localhost port 3000, just like you're used to with Rails. Now, that's kind of a lie. I mean, obviously, when you start up a Rails application, you've got to do some work on the database, rake tasks, things like that. And these can all be done as well using Docker Compose. So your commands start to look a little different, but you can essentially say, run a command within the app container, so you can do rake db migrate, you can get a Rails console, you can restart a portion of the application, not the entire stack that's running. So all those things become available to you. So GitHub, it didn't happen. If you want to check out this demo repository, GitHub, OSU Libraries, Hydra-Docker-demo, and you should be able to clone that and run it locally as long as you have Docker installed in your system. Docker is available for OS 10 or Mac OS now, Windows and Linux. So go to docker.com and try it out. That's all I got.
Thank you very much for that. as you have all been very good and kept the time precisely, then we actually do have 5 minutes for questions. We've sort of been diving into 4 really different areas, but please, to the audience, if you have questions to some of our speakers, go ahead and just tell who you're gonna ask. Yes? And please tell your name as well.
I'm Eric from NYU. I had a question for Corey. Have you used Docker to deploy Hydra in production?
No. I'm by no means a Docker expert, just a guy who really wants to stop having to install fits all the time. I am aware of people using Docker in production at our institution, not specifically for Hydra-based work, but the interesting thing there is that you can essentially take the same Docker file that you deal with in development and ship those images out to production, and then updates just become a matter of rebuilding that Docker file and updating dependencies and things like that. So possible, yes. I would certainly be interested to try it, and it's kind of on our roadmap to at least test the waters in sort of a more staging capacity, but yeah.
Other questions? Still a few minutes. Questions, please. Yes.
Hi, this question is also for you, Corey. How easy would it be, like, if some of the underlying applications actually change, like you no longer use Solar, let's say, I'm not saying that you'd actually do that, and you want to change those underlying applications, how easy is that to affect in Docker?
Sure. I really glazed over most of the details of setting that up, but in that Docker Compose file, Docker Compose exposes those services that you configure on a sort of a private network to your application, right? So when you the configuration of however you configure your app, right? Your configuration YAML files, your environment variables, whatever you use, you get a particular URL that you can use to any of those containers. So the URL for my Postgres box might look like, the Solar box might look like HTTP Solar, and Docker will just sort of magically translate that and work it out for you. So if you had another service, you could, or if you had a different dependency, you could add it as a service, assuming that there's a Docker image for it. Now you can also publish your own Docker images very easily. I don't know if you caught it up there, but one of the FC repo image that we're using is not the quote-unquote official or recommended image. It's a stripped-down image that we produced that just runs Fedora and not much else. So as long as you can find a Docker image for it, it's probably pretty easy. Was there one you were thinking of in particular? Oh, yeah.
Thank you. I think we have time for just one more quick question, a lightning question, if you will. No lightning questions? Okay. Then I just want to remind you that Stephen's slides are already on the wiki, and I'll encourage the other speakers, if you're willing, to upload your presentations to the wiki page for this session. Then let's thank our speakers. And then you have a few moments. The next session here starts in 10 minutes. 11:35. Thank you. Are Steven and Esme hiding somewhere where I can't see you? Okay. We will be now moving on with the second block of this lightning talk session. And the first speaker is Peter Binkley, who will be telling on performance profiling tools used for Hydra North. Please, Peter.
Okay, everything in this talk was already covered this morning by Trey Pendragon, so if you were at that talk, I can just go. But otherwise, if you were there, now would be a good time to catch any Pokemon in the room. We had a problem with performance starting very early in our work with Sofia 6. For Trey this morning, the problem really became acute with the 1,000-page book, which was beyond any size that they'd worked with in development. With us, it was an 18,000-item collection. In both cases, rendering became unbearably slow. Took 30 seconds to render our thesis collection page, and 8.5 seconds to render a search results page, which we lived with for a long time and finally decided we gotta figure out what is going on here. This can't be right. I should say I'm presenting the work of one of our developers, Matt Barnett, who's up in the audience and who will be, I'll be bouncing questions to him if they come up. Trey this morning talked about using a new relic to focus, to narrow the search for where the performance problems were coming up. We didn't have that, so we did a lot of log analysis and so on, and finally worked out where things were going on. And then we ended up using the same tool that Trey talked about, RubyProf, which gives you a visual presentation of where performance hits are happening and made it possible to work around it. Where Trey did this in a rake task, we built it into the application so we can see it live. And we'll get these slides up where you can see this. And you get a wonderful, clear, simple presentation like this. So I can pretty much leave it at that. The main thing is the color differences tell you where there are blocks of time being spent on a single task. So if we look at these, we see the first thing is batch processing is taking 30% of that 8.5 seconds of rendering time. It turned out this was the process that's looking at newly deposited items to see if they've finished processing, and if not, put a spinner on them. And it was taking so long to discover this that we decided to get rid of that spinner. And that saved a bunch of time. But it was still slow, and the other place we looked is in rendering the collection list. So even though we thought it had fetched all of the items it was going to display, it was still taking 28% of the time to render them. And if you look down about 5 lines where the active Fedora tags start, 98% of that 28% was happening in active Fedora. And on further investigation, we realized that in our early work, we had added a metadata field. So we had added DOIs, which we were importing from another system, and we wanted to display in Hydra. We'd added them to Fedora, but we had not indexed them. So they were not going into Solar. So every hit, every item it wanted to display, it was hitting Fedora to pull that one field out. So we changed the indexing, got those into Solar, and saved 7.1 seconds out of the 8.4 seconds that our search results were taking to render. So I guess I would second Trey's recommendations that profiling when the problem is deep really does help. We would never have, I think we probably would have taken much longer to notice that that was the problem if we hadn't really pinned it down at the profiling level. And if we end up with questions, Matt's the guy. Thank you.
Thank you to Peter. Our next speaker, I believe, also from University of Alberta, is Weiwei Shi, who's going to speak on working with the Fedora OAI provider. Please, Weiwei.
Hi, I'm Weiwei from UFA, and sorry. I work with giants, like they are all so much taller than I am. So what we do with Fedora OAI provider is we actually have a need to push our thesis, open access thesis and dissertations to Library and Archives Canada for their thesis program. So we need OAI provider for them to come in and harvest our content. So there is a Fedora OAI provider repo in the Fedora Labs. When we start using it, we identify there's some problem with it, particular because the OAI provider uses JCR SQL2 query language to generating that list for harvesting. And because Hydra and Fedora save permission separately as a subject object in Fedora layer, so we need to do a lot of join query to construct that list. And those join queries are very expensive, and on our 40K object repository, it takes about 8 minutes to generate that list. And also, we ran into that reverse collection membership problem. Everything was stored on the collection level, not on the object level. So early on, we also decided we want to save those relationships on the object level. That saved a lot of time. But still, we need a faster responding time with OAI provider. So what we did was to use a mode shape local index with JCR implementation in MapDB index to optimize the JCR SQL2 query. It is on the mode shape layer, so it basically just similar to a database index on a big database. We index some of the fields that we needed for our OAI harvesting. And the list of records, the list of records took now about 25 seconds to complete, dropped like significantly. And the complete harvest used to took about 4 hours, and now only takes about 29 minutes. And also, the memory and CPU use was dropped significantly, so that we don't need to worry too much about when someone's coming and harvest our collection, it will basically crash the entire production stack. So the process of this is generating an index with the selected field. It takes about 6 to 10 minutes to finish on our 40K objects repo and generate an index about 1 gigabyte in size. During this process, we identify another problem with Hydra/Fedora is the namespaces used in Fedora. They're not registered with a name, so they are given a random NS001 if you're looking to the Fedora interface. And that prompt a problem for us to build the index because we need to refer to those fields very specifically. So that's why we built another layer in the Fedora layer, Fedora OAI provider, to use a mode shape API to register those namespaces so that we can refer to those fields more specifically. And just so that, because we're doing a lot of those work in the customization of OAI provider, and we'll have continuous need to maintain that kind of work, we have take on the maintainer's role to maintain the Fedora 4 OAI provider repo. So we're still looking for suggestions from the community that how can we generalize our customization, because a lot of the metadata we built in our index was customization. So if you guys have any suggestions, would like to hear about that. And I'm here to talk about this on behalf of our developer, Pierpon Chawatana. So if you have any questions, I'd be happy to direct them to him. So that's me.
Thank you, Wave. And after hearing those two talks on how you're struggling in Alberta on improving Fedora, I believe now Stephen Anderson here from BPL, our host for this conference, will give us a maybe more radical talk with the title, I Love You, Fedora, but It's Over. Please, Stephen.
So as said, I'm Stephen Anderson with the Boston Public Library, and my talk is I Love You, Fedora, but It's Over. So first I'm going to start off with why Fedora for Hydra. And essentially, I did talk to some people, and I do have to admit that it does offer some nice positives. It's based on the well-documented linked data platform structure that is clearly defined. And most peer institutions are planning to use it, which means that there's a common ground for us to develop against in how we model our data. There are also a note that from Benjamin Armenter's talk earlier today about Cavendish, that there is actually somebody doing work about doing the Fedora 4 API against different backends. That might be another possibility that this talk will not go over. And the people who worked on Fedora 4 have done an amazing job, very talented people. And I don't claim that what we're doing is necessarily going to be what everybody else should do. And again, there's a disclaimer that the rest of this talk is focused mostly on the negatives and why we made our decision to move on to something else. So the first point is dealing with accessibility and how accessible your data is. And Fedora 4, a system designed for linked data, actually has no search interface within it, no Sparkle endpoint, no way to actually get your data. So you need something like Solr to even discover and really understand what's in the system in the first place. Another point negative to Fedora 4 is the speed. And for speed, if you have a Solr index that needs to be re-indexed, it's going to take forever to do so. And if you use almost any other thing like Postgres, it's just so much faster to get things into Solr, to ingest things, and to have different relationships in your system. So if you have, for instance, a collection of 10,000 objects, I think I saw a wiki page that said that takes about 30 seconds to load. And when we have collections of 37,000 items in our repository, that performance is not exactly something that is going to be easy to deal with. And there are workarounds to it, but why should you have to struggle to work around it when there are other solutions that don't have that limitation? Another point for why we want to do it is simplifying our stack. So Evan and I have all the institution knowledge, and we're basically a team of 2 here at the BPL. And if you've ever tried to show the Hydra stack to another developer, it's quite complicated. It has a different parts you have to understand to be able to actually do good development. It's very difficult to actually make progress until you actually understand all the different pieces of the stack that we have. And if Evan and I were to ever leave, it would be very difficult for the BPL to find somebody else that can maintain our code. And one of the things about a developer is leaving behind code that could be maintained by the developers, beyond just those within the Hydra community. And it allows us to use well-documented Rails backend conventions that are used by people outside the library community itself, conventions that don't change every 6 months, will have less bugs because it has many more eyes on it, and offer a wider variety of Ruby gem support because, again, it's the larger community outside of just library world. And there's also the thing of reliability, where your software stack is only as strong as its weakest link, the weakest part of that stack. So if your site is down, I often find that it's usually Fedora 4 and instances that have dealt with Fedora 4 that need to be restarted, oftentimes dealing with memory errors or something like that. Most of that is based upon Fedora 4.3, so I do know they've made many improvements since then. But still, following threads about it does seem like it's still not a 100% reliable, stable system. But again, my experience is limited to older versions right now. There's the fact that Fedora 4 stores things in RDF, and I think that that is great for search engines and great as an export format. It's something that I think is something that definitely should be supported, but at the same time, why do we have to store it natively when it's going to give me slow performance, more complicated code, and inability to even do something like order my objects very easily? And you might say, what about the linked data platform? But for the linked data platform, you have multiple different predicates that exist for any single concept, many different forms of extent, dates, whatever you have. And in each of those predicates, people are modeling the data in such different ways and trying to stick different types of elements into there as they try to force their data to work with that element, that it almost becomes impossible to parse. So if you're trying to read things from, say, 100 different linked data endpoints, it's going to almost require a different script for almost every single one of those endpoints, as nobody's actually using those predicates in the same way. There's preservation, which for the BPL has to be our Fedora layer. We don't have the money to have another preservation layer. And in Fedora 3 Commons, you could actually go ahead and get that in a human readable format. In Fedora 4, you cannot. So if you're going to have software to be able to get your content out of that system, why not just go with Postgres anyway, especially because I'd put my money on Postgres being around than just having the library community as great as it is supporting it. And this is very quickly here. So the cloud basically allows us to store things up where somebody else is taking care of the performance. We don't have to worry so much about the directory structure that Fedora offers, since we're basically using keys at that point, and we allow Microsoft, Google, and other people to handle that performance of accessing those files. And our planned architecture isn't actually that complicated at all. Essentially just using Postgres. We're going to be modeling it the same way as the mods linked data RDF groups, because we still want to support an RDF export. We still think linked data is great. We just don't think it's a storage format that should be how we model our linked data. And so we're going to still have a full Sparkle endpoint and everything else. It's just not going to be stored natively as RDF. And Solar will still remain in the front end and what our front end mostly cares about. And file IDs will still be managed from PIDs from our Arc Manager system that we already have. And that's it. So thanks.
Thanks, Stephen, for this truly enlightening talk. Moving on to Esme Cowles, who will still on the Fedora solving or dissolving. Esme will talk about Fedora 4 import and export, please.
All right, so I'm Esme Coles, and I'm going to talk about Fedora import and export. So hypothetically, if you wanted to get your data out of Fedora, this is a good tool for you. It's a command line utility. It is for getting data in and out of Fedora. And the way it's different from maybe some of the previous tools or the existing tools is that it uses more standard-based formats. The existing tools use things that are sort of tied to JCR and other internals of Fedora's implementation. This is more exporting RDF to files on disk, exporting your binaries to files on disk, exporting them in a way that looks like your repository. There's also a curation concerns background job if you don't want to run the command line tool. If you want to trigger it from inside your Hydra head, there's some functionality for doing that too. So we started out by gathering some people together, some Hydra people, some Islandora people, people who are interested in getting their data in and out in a standard formats way. We built some requirements and some use cases and sort of prioritized those for implementation. We had a 2-week Fedora sprint to sort of get a lot of the implementation done. We got exporting done and we got import close to working, but not quite. And then we had a follow-on sprint at Penn State 2 weeks ago where we sort of finished off the rough edges on import and started to think more carefully about sort of later parts of the project where supporting bags, for example, and supporting bags with profiles for all of the different persistence services so that you can have bags that will actually work with the services where you want to send them, not just bags in general. So if you have content in Fedora, it might look something like this. There's a command line utility that you can run and has the kind of options you might expect. Things like, which resource do you want to export? You can do the whole repository if you want to, or you can do a subtree or just a single resource. You can tell it where you want to put the metadata and the files. You can put those in the same directory, or you can split them up if you want to ship your binaries off to some slow storage or some other reason. You can control what the RDF looks like. So if you really want RDF XML, you can get it. And you can do authentication if your repository requires that, so it supports that. When you export, it crawls through your repository, dumps things to disk, generates a bunch of logging output, and you wind up with files, and it looks like your repository, except there are extensions to say, well, this is a turtle file or a JSON file, or this is a binary, just to keep those things separate and avoid conflicts. So if something happens to your repository and you need to import that content again, you run the import tool. It's the same as the export tool. You change one option to say import instead of export, but you point it at the same resource, you point it at the same files. Or maybe you point it at a different resource. Maybe you didn't have a disaster, maybe you just have a new Fedora that you want to import to. So it does URL translation in order to support a different host name or a different port. And it walks through the tree of files on disk, it imports those back into Fedora, and the content's basically the same as before you exported. So like I said, we export the files on disk. You can do metadata and binaries, or just the metadata if you want to do that. Importing metadata, binaries, and containers works. The containers are a tricky thing. There are a lot of things in Fedora in the LDP implementation that generate triples dynamically, and so we wanted to make sure to handle those correctly so you didn't get duplicate triples. And some triples that changed if you changed your properties, and other triples that stayed the same. So that was a mess, but that's working now correctly. And there's some configuration about authentication, RDF serialization. But there's some work to be done left. We definitely want to support importing and exporting of bags, and that's sort of the next big piece of functionality we plan to work on. We've done some requirements gathering and some spec writing so that we know what that should look like. Versions are currently exported just fine, but importing them, I suspect, would just blow up. There's also a few things, server-managed properties in Fedora parlance, things like the creation dates and the user who created or modified a resource. Those are things that you can't change with the REST API, and since the import-to-export tool is something that just uses the REST API right now, those can't be changed. But there is definitely a proposal to allow those to be changed, and we haven't implemented that, but we plan to. And there's also some things about wanting to have configurable membership. If you want to import or export a single object, you might be able to say, I want you to do everything that is linked to with PCDM has member, so that it would go and fetch everything, whether it was in a single tree in the repository or if it was spread out in different objects. And lastly, syncing with existing repository content. One of the other use cases that we plan to support is if you export from one system to another system, you might do that on an ongoing basis and just want to apply updates. And so there would be some logic for how to support that in an intelligent way. And last at the bottom is the GitHub URL for the project. Feel free to go and look at that. There are links to our issues in Jira. We'd love your help. We'd love your help writing code, but also we've had a lot of great support for people testing, people providing use cases, people engaging with us to make sure that it works and actually testing it and developing data sets. And so there's a lot of ways for people to contribute. Thanks.
Thank you a lot, Esme. There was a lot of stuff in this session for good discussion that can be done in the halls and breaks. But if there's just one quick question, I think we can do it now. Just a clarifying or very precise question to one of our speakers. Anyone? I see no hands raised. So then let's just thank our speakers again. Thank you very much. and there's a short break now until 12, where we'll continue with the last block of four more lightning talks here in the rap hall. See you then.
our workflow application for ingesting books. There's a lot to go through here, so I'm just gonna kind of click around and explain what I'm doing. This is a curation concerns application, so if you're familiar with what that looks like, then this should look familiar to you. The base of this is normally we would put in a metadata ID from our catalog where then the metadata from Voyager would get imported, but I don't want to use the network, so I'm not going to do that. I'm just going to put a title in, which you can see blanks out the metadata. I have a few options. I can add it to collections. I can decide what level of PDF is appropriate for this. Write statements, holding locations, which I also have blacked out because of network concerns. And I'll build that real quick. Again, basic kind of thing you would see. We have a file manager, which is our basic interaction point for uploading files. Looks similar to what you would get in curation concerns. I will add a couple pages and upload them. And in the back, it's generating JP2s for our IIIF image server so that it can do thumbnails in our IIIF viewer. And I promise it's going to finish. All right, there we go. So when I refresh, you can see now, please do it. Now the file manager has both pages, and each page has IIIF properties, so you can set pages to be single page, non-paged, or facing pages, which is like I've got 2 pages shot at the same time. You can say for this resource, my thumbnail's this one, and when you start viewing this thing, start on this page. I can say right to left, top to bottom, bottom to top. This is a page document, so render these things 2 up. I've got a nice little bulk namer here, so I can select all the items I want and say start it with page, and then it does page 1, page 2. I can do Roman numerals. I can foliate, so I can say recto verso, and hit save, and all of that will happen. I can also reorder, which is less important. Get over there. All right, so now that that stuff is done, when you go to the page, you'll get a universal viewer, and you can see page 1 recto. But now I need structural metadata, so I need to say, hey, this is chapter 1, this is chapter 2, so we have a structure editor for that. You can see here, I can select the number of pages, drag them over, say that's chapter 1. I can say, oh, well, this is chapter 2, and I can rearrange them. I can drop them to make them easier to move big sections around. I can drop things into other things. I can delete sections. I can say this is actually chapter 1A, this is actually chapter 1. I can move things all around. Let's do this and this. Then I can save that, and that gets saved to Fedora and gets translated to a IIIF manifest, which gives me this nice little table of contents here where I can click around and I can say, okay, go to this page. And you can see the manifest that gets generated at this URL. And if you're familiar with the IIIF manifest, this is basically just kind of par for the course. The last thing to mention is that there's a workflow system built into this. So you can see right now it's in a pending state. That's generally for for the people taking the pictures to upload all the images. And then when that's done, it goes into a new state, which is metadata review. And then our catalogers get to look at it and say, okay, is the metadata all right? And then it goes to final review, and then head of cataloging looks at it. And then it goes to complete, at which point it is available and viewable for everyone and discoverable on the front interface and gets pushed to all of our public front ends. And that's Plum.
Thank you. Our next speaker is Justin Coyne, who will tell more about IIIF in Hydra. Please, Justin.
All right, Mike and I were reordered if you were following along in the program. All right, I decided to jump in after Trey because what I'm speaking about is very closely related to what Trey presented. And most of what I'm presenting is actually Trey's work. So I didn't know, Trey, you were going to talk so much about this stuff. So if you're not familiar, IIIF is the International Image Interoperability Framework. Oh man, he's here. It's sort of a consortium of people in academia and elsewhere who've come together to develop some APIs we can do. They currently have 3 APIs. One of them is the image API, one is the presentation API, and the third one is the search API. And with the Hydra in a Box project and with other projects like Plum at Princeton, we've worked at putting these into Hydra, or at least building tools that allow us to use them with Hydra. So if you go to IIIF.io, you'll find out more about the International Image Interoperability Framework. Hey, look, the text is right there. There's their page. It's a great website. It really does a great job of explaining these APIs and how you can build tools to work with them. So let's talk first about the image API. This is Image API 2.1, which isn't all that different than the other versions, but basically, the image API says you will construct a URL that looks like this and fill in some of these variables. And some of the variables have default values you might want to use. And what it's going to do is transform the image and give it back to you. It's really useful for doing things like a zooming image viewer. If you have these originals that are scanned at tens of thousands of pixels and you really want to show someone something that's like 600 pixels, you can easily grab it and pull it down. And hopefully you've chosen a good server that caches this so that people, you're not doing these calculations over and over again. So here's an example from the IIIF website on if we provide these parameters down here, which is a region, and then a size, and then a rotation, and then a quality, you get the idea that it's taking a region and making it a little bit smaller, or squashing or stretching it in some way, and giving it a little rotation, and finally making it gray. So there are many image servers you can use. I wrote Riff. It's in Ruby. That's why we're shipping it with Hydra in a Box, because it just mounts as an engine in your Rails application. Other servers you may have heard of are Loris. That's written by John Stroop, who's not in this room because he's presenting right now. But also a quality server written in Python. And there's the IIP image server, several other servers. It seems like every other day someone is doing one of those. Okay, the second API is the presentation API. And the presentation API basically says, how do we lay out multiple images all at the same time? They came up with this basic structure that you need to have. A manifest has a sequence, has canvases, has content. And what that comes out as is like for a simple image, like I want to display a simple image on the page, you get a great big blob of JSON that looks like this. And that blob in this middle piece right here is actually pointing at the image server. So it's in the presentation API, it references the image API. And this blob isn't very important, but it allows you to do things like this. This is a screenshot from Plum. Thank you, Trey. And Trey showed you some more about this, how you can order pages, and then your manifest will have that order within it. And then you can use a viewer like this. This is the universal viewer, and it knows how to read those manifests and display them. So all we have to do in Hydra is print out that manifest from our PCDM data. And that's what the IIIF manifest gem does. Most of this work was done by Trey, and then I spent a little bit of time extracting it out of Trey's work and putting it in a gem that you could reuse in other repositories. And take a look at that real quick. There's a README here you'd have to use, It has some instructions about the expectations and how you have to model it. But in general, it's no more than 10 lines of stuff you need to add. And we are using it in the Hydra in a Box repository. You can find that code right here if you want to see how we've set it up. And then a special thank you to all these people. Like I said, we didn't do a lot of work. We're standing on the shoulders of giants. So Trey Pendragon, John Stroop, Rob Sanderson, and a bunch of people who funded me at Data Curation Experts when I worked on RIF. So that's it.
Thanks a lot, Justin. I think it's great to hear that we are seeing IIIF and Hydra sort of getting very close together. Our next speaker is Mike Jarlow, who will give an overview of this year's survey on Sofia and curation concerns usage.
Thank you.
Welcome, Mike.
Thank you. Okay, I don't really need my slides. They're not going to be very important. But so for the past 4 years, 2013, 2014, 2015, and this year, I've issued every summer a survey to the Hydra community about how they're using Sofia. And this year, I issued the same survey and asked about how they're using Sofia and curation concerns. It's really useful to me as the product owner of Sofia to know how people are using it and why they use it and what they want to see come into it, so that I can help match people up to get the right work done over the course of the year so that it keeps meeting our needs. So I want to present some of the numbers. So first, curation concerns. This was the first time we've included curation concerns in the survey because it didn't exist last year, at least not in production. And so this year the numbers look like this. There are 5 curation concerns applications in production, or at least there were 5 people who answered the survey and said they had at least one in production. There are 12 in active development. There are 7 that are planned development, and 8 that are kicking the tires. And so I wanted to tell you a little bit more about the numbers of the survey respondents. So this year there were 35 respondents, and actually it's more like 38 because a couple trickled in since I generated the slides. So over the years, this number has fluctuated a little bit, but it's been about the same. In 2013, 30 people took it. The next year, it dipped down to 20. Then it went up to 26. And this year, like I said, it's about 38. So the remainder of the data, I want to talk to you about some trends I've seen in the answers about Sofia over time. But note that this is extremely bad research, and this is my disclaimer. So the number of respondents did differ from year to year. And the questions changed a little bit once or twice. There are certainly duplicate entries in each year. There are some people who never responded to any of these and thus were never represented, and I'm not a researcher and a bad person. So I'm going to move on, and you can come to the conclusions that you will. So in 2013, I asked who's kicking the tires, and that was Sofia, and that number was 11. The year after, it was 5. The year after, it was 4, and this year it was 8. For planning to develop an app using Sofia, that number went from 5 to 7 to 7. For folks who were actively developing Sofia applications, that number started with 4. It went up to 7. It went up to 19, and this year it's at 15 as more things have moved into production. And then in terms of what's in production, in 2013 there were 5. In 2014 there were 3. Like I said, bad data. In 2015 there were 11, and in 2016 there are 19. So another question that I ask is about how people are using Sofia and curation concerns, and I got a range of answers. None of them were really new this year, but there's the IR use case with open access content. There's the student output IR use case. There's the data repository use case. Some folks are using it for digitized archival collections. Some are using it for digital collections management, and some are using it for as a digital asset manager for audiovisual materials. And then the last question that I ask is what you want to see come into Sofia and curation concerns so that it can keep developing the right features at the right time. And so the number one this year was approval workflows for mediated deposit and for other use cases. That has been in the top 3 for the past 3 years, and now we're finally working on it together, which is great. The number 2 feature was an administrative dashboard. That was also in the top 3 for the past 3 years, and we're also working on it right now. So it's coming. It's happening. The third requested feature was better batch functionality. And the fourth, there were many runners up that they're all clustered together, like more robust metadata, more easily configurable metadata, more features focused specifically on research data, and a greater focus on APIs. So in terms of the roadmap, I have generally followed what folks have asked for, given the capacity that we have as a team. And so we're going to keep working on the features that I just mentioned. And if you're interested in seeing others bubble up and get worked on in the next 12 months, please reach out to me, and I'm happy to plan community sprints with you. Thank you.
Thank you, Mike. Our next speaker is Eric O'Hanlon, who will give an update on Hyacinth 1 year later. Welcome, Eric.
Yeah, I may or may not have the right adapter, but just in case I have my presentation on a flash drive, I'll just try that.
Here's, there was an HDMI, and then there must be. Here it is. You have HDMI. Well, then you can use that. And then you connect it like this.
All right, there we go. I need a new laptop, so if this starts flickering and doing weird things, just know 6 years old, out of warranty for 3, crazy things. I haven't plugged into an external device in about 2 years for that reason. I'm not kidding. Here we go. But still, let's push out as many pixels as we can. All right. There we go. Hey everybody, I'm Eric O'Hanlon. I'm from Columbia University. Some of you may have seen me last year talk about Hyacinth. I did an unconference session, talked for about 40 minutes. This will be much faster because I know this is a lightning talk. So we'll get right into it. 3, 2, 1. All right, what's new? So this year, I have a beard now. That's new, but that's not what we're here to talk about. We're here to talk about Hyacinth, right? So what's new with Hyacinth? That's the question. So we've got... All right. Okay. So, anyway, I don't know what that's supposed to be about, but Hyacinth has, okay, sure, a beard and new features, we'll say. That's one way to put it, I suppose. But, I mean, where would I go with this? I guess we start with B. Okay, sure. Yeah, so this year, new feature, batch import, and that is the first of our set. That is batch import through CSV. That's one new thing that we've been working on for a while, where we wanted to say, we've got these old collections. Oh, and apologies for anybody who went to my poster session. This might be slightly redundant, but I'll try to keep it new. We've got batch import in the form of CSV, so you have a whole bunch of CSV headers, things like defining a project or a collection or any one of the dynamic fields that are defined in Hyacinth, title, author, publisher, that sort of thing. We do it through a spreadsheet import. That's been useful for us. The next thing we have, E, is export to. So it goes both ways. Hyacinth round trips metadata for your records. You can do a batch export, do some corrections, do a batch import. Eventually, we're going to have in-app batch correction features, but export and import through CSV has been our major way of doing it. Moving on, we've got we've got automatically queued image derivatives, and that was important for us because whenever we push new content into Hyacinth, which is the wrapper around our Fedora repository, we want to be able to also publish the stuff to our front-end digital collections application. So generating automatic derivatives is helpful because you put in 10,000 new images. You don't want to have to manually start that sort of thing, so we have that interacting with our repository cache, image server, IIIF server, sort of all in one image handling application. We've got the resolution of URIs in Hyacinth. One thing that we had wanted to move toward last year is we were storing everything as string values, lots of nested fields. So you might have a name which has a type, and it may have a role hanging onto it, and that role has a certain label, but it also has maybe a code that you're using. So we're big on URIs now, and for a number of fields, things like subjects and names, using those internally. We have a gem URI service that I had mentioned at IRC yesterday, but I've had some good conversations with a couple people since then. It seems that there's other very similar work going on, and I will ideally be working with Stephen Anderson and others looking into working on that rather than just creating a redundant parallel sort of a project. D, I didn't actually have anything for D as far as new features go, but I guess demo, that might work, yeah. So let's do that. I'm taking a real chance on the internet here, but I figured that after all the talking about Hyacinth, it would be useful for anybody who hasn't seen it to actually show it. My laptop is freezing up though, as I thought it might, so we'll have to wait one moment. There we go, okay, good. So will the internet be kind to me today? There we go. All right, so every time that I talk about Hyacinth in a meeting at work or anything, oh, woman, thank you. Every time that I talk about Hyacinth at work, people say, okay, well, you talked a lot about it, but I'm not really getting what it is visually. Can you show me? And so the demo usually helps a bit. I'm going to speed through this because I'm low on time, but here's the interface here. You'll notice it looks in some ways like Blacklight, where you have your search results, your facets on the side, that sort of thing. Got a couple of extra custom filter fields. In Hyacinth, you define any field that you like, and you add certain properties to that field so that it's indexed in a particular way. So title is a good example. You define a title field, and you say for the, let's say for the sort portion of the title, we're going to make it keyword searchable. You could optionally make it a facet field if you wanted to. But the idea is that you can define any field that you want, and you don't have to redeploy your application or change a configuration file to add or remove new fields. That's the big thing, and you create any field that you want, and you serialize it however you want. Right now, it's in the form of XML data streams. Eventually, we'll move to RDF when we get Hyacinth from Fedora 3 to Fedora 4, but here's a quick preview of what this looks like. We've got some XML serialization rules where we say, we happen to use mods, so we say, all right, so for this particular field, we have a project display label. We're going to create a mods, or inside of a related item element, we'll create a title info element, create a title element inside of that, and create content display label. But if anybody's interested, because I'm low on time, if anybody's interested in talking more about this or seeing more of Hyacinth, let me know. Stop by. I'll have my laptop on me, and it won't be connected to a projector, so I'll feel confident that I can show you things working. So thank you, everybody. Thank you.
Thank you, Eric. And that was our last speaker for this session. Is there any very quick question to any of the speakers? And we have 1 or 2 minutes. No, I guess lunch is calling. So this concludes the lightning talk session for this morning. Let's give a hand to our last 4 speakers. Thank you, guys. And to the speakers, may I remind you to upload your presentations to the wiki. That would be great. Thanks a lot.
I'm going to give people just another minute to trickle in from lunch. And I'm going to talk for the half of the time I've been allotted, and then hope for some robust Q&A from people in the audience, because I'm sure that there are people in the audience who are further ahead than we are on a parallel track to what we're doing, or even have experience to contradict some of the information I may present. So feel free to come forward in the room, because I really want to share the platform for some open discussion, and don't want the auditorium format to prevent us from doing that. So I guess I will get started. And first of all, apologize for the embarrassing mistake in the title. You will see in the image of the program that it says open source content, not open access content. That's my fault, and I obviously was in a hurry. Obviously the ideals are the same, but you may have wondered, what is she going to talk about? So my name is Linda Newman. I'm head of digital collections and repositories at the University of Cincinnati. And I want to credit my colleagues, Glenn Horton, who's here, developer, James Van Mill, developer librarian, and Mark Konechny, our scholarly communications strategist, who are actively doing the research, investigating the policies, and starting the software development, and should therefore be credited as contributors to this presentation. James and Mark could not be here today. Yesterday, in the State of the Hydrosphere presentation, Tom Kramer said that we needed to move beyond focusing on the researcher depositing to our repository and look at other relationships. And he mentioned several of the APIs and services I will discuss here. As he said, we need to locate the repository in the broader scholarly publishing ecosystem with a real emphasis on APIs. By the end of this presentation, I think you'll see why I agree with this, but I hope you will also agree that we need a bigger, less reactive vision of where we fit into this landscape. So, University of Cincinnati's repository, Scholar at UC, has been in full production mode, announced to the full campus since early 2016, this year. I think about February is when our press release went out campus-wide. Growth and adoption, not unexpectedly, has been slow but steady. The repository has a mission to preserve and make accessible our institution's academic output. This includes much more than articles. Includes ETDs, video, images, data sets, research notes, courseware and classroom video capture, university digital official records, including potentially website archiving and social media. We're nearing production of some batch methods for ETDs and content coming out of our legacy repositories. And we're about to put into production a method for bringing in video from the campus-wide system for streaming, which happens to be Kaltura. These efforts will definitely increase content, but our dean is hungry for more content sooner and suggested that we start seeding the repository with open access articles and preprints where copyright allows. And I should say that my slides are meant to only be evocative, to give you something to look at that maybe will have help provide some context to what I'm talking about. But when I upload the slides to the wiki, all of my notes will be connected to the slides so that you'll, because the slides themselves won't necessarily say what we're talking about. I tried to find a nice meme about being hungry, and I couldn't find any meme that didn't violate our code of conduct. So I just stuck with this message here of more and more and more. So some facts about us. We're a relatively large research university, this fall projected to be 45,000 enrolled students. We have 15,000 employees, of which about 6,600 are either full or part-time faculty. And a relatively small library staff, only 106 of us, staff and librarians across 10 libraries. That includes our health sciences library. So, making any sustained manual effort to consistently obtain our faculty's research output is questionable. It's why we launched the repository as a self-submission system. So you can see if you can see the little tiny green sliver, that's us in the libraries. We have an existing homegrown campus research information system, what some people might call CRIS, or Current Research Information System, what we call our research directory. initially developed for the medical center that is engaged in, and this system, the research directory, is engaged in building online profiles with research and grant citations for every faculty member and researcher. They are using the family of Scopus APIs to populate this online directory with citation data. Now, ORCID, interestingly, uses the same family of APIs to build ORCID profiles. So, and the libraries, in fact, negotiated the contract for the Scopus family of APIs. So as this service is already in use to build citation data, we are interested in whether we can get the articles themselves using the same APIs. We have endeavored not in our mission for the repository to compete with the research directory. This gets complicated, though, when we look at how we might integrate Scholar at UC into the landscape I'm discussing here. Third fact about us is that we have no open access policy, not only no mandate, no university policy with a position one way or the other towards open access. So we have two potential pilot approaches we are looking at now to seed our repository with some content. As a demonstration, probably not an effort we can sustain, contacting a small group of faculty and asking for a copy of their current CVs. Uploading works as a result. There's a recent article from Juan Lee of Princeton describing this approach combined with using Web of Science to retrieve and format the metadata for batch load into bpress. And I've thrown up the URL there. In other words, they're doing something very similar to what we envision, getting faculty CVs, manually probably enlisting students to retrieve the actual articles, verify some copyright parameters, and then what they are automating is retrieving the metadata using Web of Science so that they can then put together a batch load. For the faculty, the initial faculty we reach out to, we are thinking that we will approach faculty that we see are publishing in academia.edu or ResearchGate. This indicates that they're pro sharing their content, even though we're disappointed that they're in a way using the competition. We will probably use student labor to build the data set and then batch load it. We would link the articles to the author's identity in our repository so that they could delete the article, edit the metadata, or replace it with a different version. We're completing a development task to allow a work to be owned by someone who is not yet logged in without setting a temporary password or making it look to our system like they'd logged in, because we show a welcome message the first time they do log in. So that's an interesting development task. We'll send an email to faculty once we've done this, but they'll of course know that we've picked them for the pilot project. By the way, I had some interesting correspondence with academia.edu asking if they had an API we could use to pull or push content, and the response was, well, if you pay us to develop it, we'd be glad to do that. So. The second pilot is to look at those Scopus API, family of APIs that we're already licensed for, at least in a semi-automated fashion to build a data set for batch load. Email correspondence with Elsevier, and Elsevier produces these APIs, established that only ScienceDirect out of their APIs would clearly identify which articles were open access and provide links for obtaining the articles themselves. We were able to retrieve 6,401 records for works from 2011 to date, where the authors were from our university at the time of publication. We narrowed that down to 749 records that were marked as open access. We further narrowed this down to 301 records that did not have Elsevier's confusing rights terms attached, terms that we're still trying to decipher. So we hope we can go back from 301 to 749, but we're going to have to talk to Elsevier. We then took a look at the data for those 301 records to see if they could be matched with specific persons in our university's authentication system. Author disambiguation quickly became a real concern. The ScienceDirect API often gives us last name and initials and not full first names. So this is a real world example. If the author is Zhang, initial Y, initial J, and we have 5 Zhang Ys who are all researchers in the sciences, you can see the problem. But with attention to specific discipline and Scopus IDs, it still seems a possible, but perhaps for only 301 works, a manual task. We need more ORCIDs. So the plan is to build the batch load set batch load it, make the results public, and then notify the authors, letting them know that they can log in and even delete the work if they choose. So the results from Science Director, of course, vary domain specific. We're looking at other sources that may broaden the subject content, although the hard sciences may still dominate. Using the list of journals that allow deposit into an IR that's provided by Sherpa Romeo, and combining this with the Scopus API itself, we'll get more content if we can rely on that list to reliably identify articles that should be open access. We could approach open access journals directly, such as PLOS. I think we should investigate the JISC router. It's been around for a while. Some of you may have some experience with it. It offers a notification service that does include full text and what I've learned to call AAMs, Article Accepted Manuscripts, which basically I think means preprints. And it offers 3 methods of getting the content to you. Push, using SWORD to deposit, which by the way is already operational for DSpace and ePrints, an API pull, and an OMI PMH pull. JISC is out of the UK, of course, and it seems the most heavily used there, but they do note on their website that they're accepting new clients. Another method is to emulate the excellent work done at Notre Dame to pilot the Open Science Framework with a customized deposit portal for the final output to our repository. We're in the stage right now, though, of trying to find some researchers who will agree to use OSF for their next research project. And then using the Share Notify service, also from the Center for Open Science. I'm continually impressed with the scope of their work. The Notify service has now an institution filter. I think this is new with the Share 2.0 discovery layer. It doesn't seem to work for our institution at University of Cincinnati, perhaps because we have not yet shared any of our content with Share. But a search on University of Cincinnati as a string in quotes does find some articles. Share does talk about the problems with institutional identification on their FAQ. Rick Johnson, who's here at this conference, has reported on the work in the recent Share community meeting and hackathon to improve Share metadata. And I think that institutional identification may be part of those improvements. However, it's not clear to me whether Share is designed to help local institutional repositories retrieve content already published elsewhere, as much as for reporting out and discovering from a variety of sources what is published. If Share can serve the former need and aggregate several sources, it could be a major tool for aggregating content, but I'm not sure that this is its mission. The Center for Open Science is also supporting an effort to build a preprints platform that can be replicated for each discipline. One of the newest ones is called SOAK Archive, soakopen.org, and COS describes their general preprint server for replication as the Open Preprint Repository Network. You can search all the preprint servers at once, and it's also included in the Share Notify service. So you can search through the Share Notify service or through a discovery layer just for the preprint servers, the giant archive, which is mostly math and physics, the new bioarchive, SOAK archive, engineering archive, and psych archive. Quick look at what's operational makes it look like we have the same problem right now with Share, with the preprint network that we have with the Share Notify service in general, in that it doesn't offer good institutional identification of authors. Again, that's probably not its mission. But I'm hopeful that institutional identification might be in the near future for this preprints platform. After all, with most of our academic publishing still non-open access, it is only the AAM, or preprint, that our authors can deposit. If we want that content to live in our IRs, now I'm preaching, this preprints platform is initially both another source of content for us, but also another source of competition. Just as are the federal repositories, such as the Department of Energy's Pages repository, PubMed, the Department of Transportation's repository. It seems almost every plan developed by a federal agency to date in response to the OSTP memorandum on public access of federally funded research establishes another federal repository. With these multiple federal agencies building discipline-specific repositories and subject-based preprint repositories and other subject repositories coming online, and academia.edu and ResearchGate showing popularity, how do we expect a researcher to choose the local IR for deposit over these repositories that might be either mandated for funding or specific to their field. So, should somebody do this for us? If we use all these services to broaden our subject coverage, we may find that we have a significant deduping effort. That alone may suggest that we need a service to do the work for us. At Cincinnati, we may find ourselves soon exploring commercial services like Symplectic Elements, Figshare, or OneScience.com from Science Metrics that claim to do this aggregation work for you. And I know some of you have experience with Symplectic Elements, particularly in the DSpace environment. Figshare seems to be a repository itself. Figshare and Elements have the same parent company, Digital Science. OneScience.com is a newer offering coming on strong with tools like OA Finder Plus, which claims to, quote, help librarians populate their institution's repository with green, gold, and hybrid OA papers. OA Finder Plus helps you fetch freely available versions of the papers authored by your institution's researchers, no matter where they are archived in the world. And we also heard today in the Archivematica research data presentation, the very first track this morning, that libraries in the UK are using Pure from Elsevier to retrieve metadata and content for published data sets. I'm a little nervous about using these commercial sources because they do also have their own repository platforms to promote. So I'm a little nervous about ceding this territory to them, but I'll talk about that a little bit more in a minute. Symplectic Elements provides a researcher's dashboard and email notifications to encourage faculty to routinely deposit into their local IRs, helping identify what publishers allow. The service seems designed to help faculty and researchers comply with local open access mandates. Full text is provided from either Archive or Europe PubMed, so I wonder if this includes some of the other full text sources that we have identified, but that's something we would talk to Symplectic Elements about. There are plenty of use cases one can find in discussion lists that indicate some significant success in populating repositories using Symplectic Elements as one strategy. And I'll quote Catherine Mitchell of the California Digital Library, who wrote on a discussion forum called Lib License L recently in July 2016, that after a year and a half of open access policy for the University of California system as a whole, they had added nearly 13,000 works, credited to a combination of librarian outreach and the use of Symplectic Elements. Quote, what we are able to do via Elements is create a corpus of publication records for faculty, which they can then accept, reject at the click of a button, and then simply upload their AAMs into our system. Sounds great. Elements does involve the author in first approving the submission and asking the author to provide the AAM if Elements can't find it. So that is a little different than our concept of using the Scopus family of APIs to just go ahead and put the content in and then tell the researcher or faculty member that we've done so. And since we don't have an open access mandate, there's a good question about whether any of our faculty would pay any attention to the emails they might be getting from a system such as Symplectic Elements. So we might ask, would the cost of a commercial system be warranted without an open access faculty? Of course, it could be a chicken and egg problem. Having Elements might encourage development of such a policy. Like the JISC router, Symplectic Elements already interfaces with DSpace and ePrints, and I believe that some development work for Hydra Fedora would be required. And you heard mention in this conference from, I think, Jim Tuttle of Duke about an interest in forming an interest or working group to talk about this very subject of making Symplectic Elements work with Hydra. So, could the open source community do it better? There was talk at the SHARE community meeting of a San Diego project to build a scholars dashboard. I wasn't able to attend the SHARE community meeting, so I'm relying by the reports out of that meeting, and I encourage any of you to speak up in the Q&A and let me know if, in fact, I'm reporting this incorrectly. So I'm not sure if this scholars dashboard is in the same space, the same conceptual space as the Symplectic Elements dashboard. But if it is, I'd certainly welcome that effort. It's being developed by UCSD and SHARE. I don't know if Declan Fleming is at the conference today or other people are here from UCSD who could comment. It may not be clear to our stakeholders why we want published, readily available articles or preprints for our faculty's articles stored in our IRs. We may trust ourselves more than external repositories and commercial entities to preserve this digital content and believe that gives us a justification for using these various services to retrieve and store said content. But that preservation mission may be something that our own faculty and administrators regard as a library and not an institutional interest. They may be more concerned about the access and showcasing mission, being able to highlight our own faculty and researchers' works. In this regard, we have national efforts underway with ORCID and Vivo. We have a pilot project with our research directory to look at combining the use of ORCID in a way to tie together the repository and the research directory so that if a researcher wants to publish a citation from something that's in the repository to ORCID, it will show up in the research directory and vice versa, so that we aren't forcing our researchers to make a choice about whether to maintain their profiles in our local research directory or on ORCID. I guess Vivo could be added to that equation. But perhaps in the repositories themselves, we need to have more work records that are citation only. This may be partly what was discussed recently on the Fedora Vivo Integrate Google discussion group, which I encourage you to take a look at. However, this still leaves the focus on reporting and not collection of publications. What more should the IR and open source communities be doing? Could we envision a publication and data router so that we will not be giving our faculty and researchers the sense that we are competing with all these other repositories that I've mentioned in this presentation? Our researchers will undoubtedly only want to upload a digital file once. Should we think about a simple deposit mechanism for those publications, one that won't leave out institutional repositories? In the context of the Vivo Fedora integration discussion I just referenced, I want to credit Stuart Chalk, who is, I believe, a scientist in the field of chemistry who's been working with Vivo, and for making this very suggestion. Quote, faculty are being encouraged to put their work on ResearchGate, academia.edu, Mendeley, etc., as well as linking presentations on SlideShare and other social media sites. Why do faculty not have one central location where they can upload the papers and presentations that describe their work? If there were additional tools to then automatically upload these papers to the other sites, faculty would not spend as much time advertising themselves and be able to do more research. This may be the return on investment that might be a more powerful selling tool to our faculty than the preservation mission, which they naively trust us to just somehow accomplish, if we can show that we can actually save them some time. A similar idea with a focus on compliance with federal funding mandates may be in the works from the Center for Open Science and Share Initiative. I'm quoting here from a summary of the Share community meeting that was sent to our Dean of Libraries, and I haven't found this reported on the Share site itself. But there was a demonstration of a new app that the Center for Open Science has developed in response to conversations with CENDI, C-E-N-D-I, a federal coalition of science and technology agencies. The app is designed to be a simple deposit mechanism for researchers, sponsored research offices, and libraries to assist with compliance with federal public access plans. Virginia Tech and OSU have agreed to pilot the app. This is sorely needed with the diversity of federal repositories that are coming online so that you know, depending on where you get your funding, where you need to deposit your work. But it would be great to build such a tool in a way that when local institutions used it, the citation was added to Vivo, to ORCID, and a copy of the AAM or article, if it's open access, was also put into the campus institutional repository. I hope that this last aspect is included in this development of this app, or if not, that the open source community can consider what it might take to move from just trying to pull content, which will be a thankless and endless task, to pushing content out into the scholarly communications landscape. That's why I have this funny door sign up on the slide. So, in summary, it's a confusing landscape with a lot of effort combining automated and manual methods. Facing up to duplication and disambiguation concerns, we can start to harvest open access content and AAMs into our IRs, the open access articles and the preprints. But our stakeholders may not understand or appreciate why we are doing it. The preservation mission may not matter as much to them as to us. I'm basing this on actual interactions with our faculty when I've tried to promote the IR that preservation causes people to glaze over when I'm not talking to librarians and data scientists. We need to show added value that means something to their research lives, the ability to populate their ORCID and Vivo profiles, the ability to send the content for them to the federal or preprint repository of their choice and mandated by their funding. Those institutions with open access mandates, perhaps using services such as Symplectic Elements or the other competing services I mentioned, such as onescience.com, may be more successful in getting faculty to deposit to the IR and to an external repository, to do 2 deposits at least, one to the IR, one to their repository mandated by funding. But ultimately, I believe those faculty will bring up the same added value question. If we cannot manage the connection for the faculty between the local IR, the federal repository, and the subject domain repository, it's time for the open source community to look at the complete environment of scholarly communications. Wouldn't it be great to move beyond citation reporting and article harvesting mechanisms towards positioning libraries to be the publishing center, the publishing router for their institutions, pushing content from the IR to elsewhere? So I hope you don't mind that presentation that was full of some opinions from me, and hoping that you don't mind the auditorium format, that we can now have a bit of discussion, both about what y'all are doing at your institutions, because I'm sure you're grappling with the same issues, and where we are at Cincinnati. Yes. We are. We're using the Curate gem. Yes. Now, to be clear, we haven't done it yet, but our intention is to, we think we will be able to emulate the process as if they had logged in themselves and loaded the work, that the end result will show that they are the owners of the work. Right. Yes. Even if they had never logged into our repository using our shibboleth authentication system, the first time they do, they should see the work as something owned by them that they can edit or delete or replace. In order to do that, we're having to really look at the underlying object structure of people objects, but we think we can do it. And we're close to finishing the development to support that. Okay, sure. And of course, there's a policy decision to be made. We could load these works so that they're owned by the individuals, but they're private, and ask the individuals to log in and brighten them. What I hope we will do is just load them already public and tell the individuals they can go in and darken them or delete them if they want to. But it will be interesting to see what kind of reaction we get to that. Yeah. Oh, okay. Thank you. Was there a question in the back? Yeah. We could. We don't actually have a mediation system in place right now that would make that a little bit easier to model the workflow for. So I think what we'd have to do, if we wanted faculty to be involved at that level of involvement at that level before we made the work public, is we'd have to load it in a private, marked as private, and ask the faculty to essentially approve it before it went public. Yeah. It's certainly insufficient for author disambiguation without some fancy footwork. And that's the main thing we're looking at right now, is can we, with any of these sources, identify who was a University of Cincinnati author at least at the time of publication. And the metadata we can find may be insufficient from a variety of ways as well, but we're starting with just that question of author disambiguation. So I was hoping that there might be people in the audience who've used some of these same tools and or the JISC router or symplectic elements. If you have any experience to share along those lines. And feedback if you think this is just totally crazy too, so. You know, one of the pitfalls the very first beginning of the presentation, I talked about how our repository is for more than articles, and I don't want people to think it's only for articles, and if we don't get everyone's articles, it's not successful. Because there is so much digital content that is not being preserved, that does relate to the academic history of the institution, but it doesn't necessarily get presented as a published article. That certainly includes courseware, video capture systems, even things like syllabi, which are something the library used to collect in paper form. So I think in some ways it seems a little bit too traditional to me to think just in terms of published articles, but I am, of course, responding to my administration's desire to seed the repository with that kind of content. We don't think we have the staff to continue on a perpetual basis to keep pulling the content in. But we think we can seed the repository, unless we would contract with a service like Symplectic that could possibly do it for us. But we think we might be able to seed the repository with enough content to maybe get a little bit more press for the repository to help our promotion effort. So that alone is a question worth discussing, whether that's a good tactic for promoting your repository. Yes? Thank you. So, and I may have mistakenly credited you, Jim, as the person who spoke in the lightning talks on day one about starting an interest group. No? Okay. Great. Yes. I think that's a great example of return on investment. And I'll mention that we're, at Cincinnati, we're trying to integrate right now the Orchid gem from Notre Dame, which is a Hydra gem. When we have that integrated, our researchers will be able to, from the Hydra profile page, query Orchid and pull in their Orchid ID. But we hope to then take it much further and do things exactly along the line you're describing. And we'd also like to be able to give people an option to share a work with Orchid, share the citation essentially with Orchid, and also our local research director, our local Chris. But I think that Orchid will really help with that author disambiguation part of it. So the first step is we're just trying to integrate Orchids with the repository and use the Orchid gem from Notre Dame. Orchid just changed their policies on how you mint orchids. They want you to go to the website now to mint them. They don't want you to use the API to mint them. So we're working around that, but we can still use the API to retrieve them in an accurate way. And when we do that, and I don't claim to fully understand this, you're giving if the researcher uses the API as integrated into our interface to query Orchid, they're essentially giving us permission to retrieve the Orchid content, so that permission step is something we want to get into the repository. So are you, once you have that Orchid ID, are you in your feed combining what's in the repository and what's just showing up on their Orchid profile in that feed? Right? You mean Notre Dame might pull it back? Is that? Yeah. Right, right. Of course, we have multiple threads, so we're also trying to push along to Fedora 4, but so sometimes progress, like for any of our development teams, seems really slow, but just having a roadmap of how we're going to tie these things together, I think, is important, or how we hope to tie them together. I think the difficulty that we're having to wrap around in our presentations about the repository are the return on investment, why our faculty should care about their content residing in a repository that's actually taking active steps to preserve it. So these kinds of added values of being able to leverage the integrations with Orchid or Vivo, or my wild idea of being able to push content out to other external repositories, I think really help with that equation. It's a lot of work ahead of us, though. Yes. Well, we do have a UC, or University of Cincinnati, implementation of Box, but it is not used consistent across the campus. And what we're finding is that departments, it's very decentralized, and departments often have their own electronic lab notebooks that are the system they prefer. You know, maybe the Department of Chemistry wants one particular system because it supports ChemDraw, and engineering has a need for another system. So they're all using different methods, if they're using any method at all, to support somehow collecting their research. I think this is really the space the Center for Open Science with the Open Science Framework is wanting to help push along so that there's more support for open science. So I'm excited about the idea of trying to find a couple of University of Cincinnati researchers to try the Center for Open Science Framework, but it's been hard to talk about pulling them away from their current proprietary tools for research management. That's yet another ask that, you know, ask them to learn something new, to do something new, to apply a different method, and the benefit that we can, at the end of the process, perhaps develop a custom portal with our repository. Again, that may be something they see as a benefit to us, being the libraries, not to them, unless we have a broader vision. I'm speech making now, sorry. But at the University of Cincinnati is surprisingly decentralized. The Office of Research is not very proscriptive about these, and it seems that each college and department has its own methods. I see Glenn in the audience, and want to thank Glenn again. Glenn is doing the development that it's Ruth from Notre Dame asked about with regard to how we are going to load content and have it be owned by someone who hasn't logged into our system yet. Well, I appreciate you being here. I appreciate the reality check that no one stood up and said, I've said things terribly inaccurate about symplectic or JISC or the Scopus APIs or what is an AAM versus a preprint. But I hope more of us will start pushing the boundaries of this space and not being kind of reactive to what the publishing industry hands us. Mm-hmm.
Good afternoon, and welcome to this panel session on migrating from Fedora 3 to Fedora 4. My name is Jim Coble, and I'm from Duke University, and I have with me here today Adam Weed from Penn State University, Julie Hardesty from Indiana University, and Michael Friscia from Yale University. We represent 4 institutions, each of which are in somewhat different places along the way from have migrated Hydra Fedora repository from 3 to 4 to are planning, dreaming about how to do such a migration. And so what we plan to do is each of the 4 of us in turn will talk for about 10 minutes about what we've done or what we are planning to do or what we're in the process of doing. And that should leave time then at the end for questions from you guys, and also, and perhaps even more interestingly than any answers we might come up with would be comments and things that you've experienced in your attempts to migrate or successful migrations or planning for migrations. So, Adam.
Hi, I'm Adam. I work at Penn State University, and I'm going first because we've actually migrated successfully, and we're going to be migrating again, which I could also talk about. But first of all, I'm going to put a timer on myself, because if I don't, bad things will happen. So I started working for Penn State in April 2014, and just shortly after that, I was tasked with migrating our Fedora 3 repository to Fedora 4. We were a Sofia shop, still are a Sofia shop, and we were running Sofia version 5 at the time. And Fedora 4 was still under development. So we had a unique opportunity to do this while Fedora 4 was still being finished. And if we encountered problems, we'd be able to have those changes pushed into the software before it was released. So PCDM was not around. I think it was under discussion, but it had not yet been implemented. The approach that we took was to basically export everything out of Fedora 3 and then re-import it into Fedora 4. So it was basically, I characterize it as a database dump and load. Like if you do a MySQL dump or Postgres, it just dumps out a bunch of files, and then you would reload those files and it recreates the data in your database. And I wrote a gem called Fedora Migrate that's in the Project Hydra Lab space. And I apologize that we don't have any slides, so if you need any of this information later, please come up to me. I can point you in the right direction, write it down for you, or give you my email information. You can get it from me later. So we imported or exported the data using all Ruby code because we were running Sofia. We used a gem called RubyDora, which was part of the old Fedora 3 Sofia 5 stack that could access your Fedora 3 repository using a Ruby API or Ruby language, and then using the updated code base that used Sofia 6, we remodeled our data. No, no, we did not remodel our data, but we updated the code to be compatible with Fedora 4. So the process was you have a Fedora 3 instance running, and you have a new empty Fedora 4 instance running. With the Fedora 3 instance in read-only mode, you iterate over your entire repository and retrieve a list of all of your objects, and you save that list as a JSON file. And then in the next step, you would then look at each object in your Fedora 3 repository, and it would pull out the data and look for a corresponding model in your new Fedora 4 Sofia instance. And it would simply just go like a one-to-one process that's down the list, moving each object. And then I set up different movers. So you'd have an object mover, you'd have a data stream mover for binary data, and then you'd have some RDF conversion. We were fortunate in the sense that Sofia 5 used RDF descriptive data from the get-go in the form of an N-triples data stream, which was basically it was a text file. It was a Fedora 3 object with a data stream that contained text, and the text itself was triples. So using that, I could convert that to RDF and place it in Fedora 4 relatively easy without much trouble. It would have been more challenging had we had XML, for example, like mods. I was just coming from the mods group, and that's another whole other can of worms. So we didn't have to do any XML to RDF conversion. The one problem we did run into was that where the relationships were specified in RELS-X, for example, you had parent-child relationships in the forms of collections and batches. And if you tried to, in Fedora 4, create a child with its parent, and the parent did not exist, then that would create an error. So we had to go through and iteratively add the relationships afterwards. So it was about a 3-step process of, well, actually 2 really. So the first step, you would put in all the objects just individually, but without any linkages to them. And then in the second process, then you would go through and establish those linkages, which was the RELS-X data stream essentially. And then sort of bookending that process, one of my colleagues, Hector Correa, who was working with us at the time, wrote another set of scripts that essentially, they sort of monitored this process. It was like a checksum, if you will, where we would go through the Fedora 3 repository again, but not using RubyDora, using I think just direct access through its API, retrieving a list of objects and their types, and then store that in a database table, and then run through our migration, and then at the end, sort of recheck our work. Did sort of like double bookkeeping, this object made it over, okay, it's a generic work, okay, it's a generic. This object made it over, it's a collection, yes, and that worked out pretty well for us. The actual execution of the migration was problematic. Tomcat blew up on us a lot, and instead of actually trying to fix Tomcat, we just sort of jerry-rigged it and just would restart it if it would fail. When I mentioned that in the first process, it creates those JSON files. So it's creating a report file for every object that keeps track of what got moved and what didn't if there were errors. So if in the process, that first process of migrating each object, if it found something that didn't work, it would just, or some exception was thrown or something, it would just make a note of it and move on. And then so if you started up the process again, it could go through and say, oh, well, this one didn't make it, I'll just move that over. And through, I think it took like 2 or 3 times restarting it. It finally moved all the objects over. And it took about, I want to say 12 hours or so. We had 24,000 odd objects, not too many, and the total size of the repository was about 200 gigabytes or so. So it really wasn't a large amount of data. And then after everything was moved over, we then spent another couple more months QAing everything, and then went into production with our Sofia 6 instance on Fedora 4.0, I should add, in April of 2015. So now what we're looking at is we have to do another migration of Fedora 4 to Fedora 4 plus PCDM, which is Sofia 7. And for that process, we're going to essentially do the same thing we did before, and dump everything out and put it back in again, because now we have our model has changed. Sofia 5 and 6 used a file-based model where you have a generic file that contains the binary and the description together, and Sofia 7 with the PCDM model is different. It's a work-based model, so you have a work and a file. So we're essentially taking our generic files and breaking them into 2 pieces with the work and the file set and the binary contained into it. I think that's about it. I still have 2 minutes left. One other thing, that when we were migrating, we could copy the descriptive data if we needed to. We didn't need to, but we would have if we had XML. but the binary data was read out of Fedora 3 and read right into Fedora 4 at the time of migration, because we could have two repositories up and running. And checksums were run along the way, so we knew that the data was making it over. And we did have one other problem we ran into was, oddly enough, character conversion, because we had the people that were uploading, putting in descriptive records into ScholarSphere, that's our institution repository, the Sofia application. They were doing things like cutting and pasting from PDF documents. And so we wound up with some really odd characters that were in these fields that would just not convert to triples. They would not. So we had to do some somersaults, like convert it to 8601 and then convert it to UETF and do a couple of things, and then it finally worked. But that was kind of fun. Or not fun, challenging. Learned some things. So yeah, I got 40 seconds, but I'm done. So I will move on to Jim, and we will revisit these things later.
Thanks, Adam. Again, I'm Jim Coble from Duke University. When I proposed this panel and volunteered to participate in it, I thought that I was going to be able to report that we had also, following on Adam and Penn State's successfully migrated from Fedora 3 to Fedora 4. And the picture is somewhat more complicated than that. We actually have been there and back again. So I'll talk about that as we get near the end. So just a little context, our repository, the Duke Digital Repository, was launched in the summer of 2013. We have two Hydra applications, a staff interface and a public interface. And as of just a few moments ago, I checked, and we have just over 390,000 objects in our repository, and I think the space footprint is somewhere in the 9 to 10 terabytes worth of data there. We began work on migration to Fedora 4 in fall 2015, and we very happily were able to contract with Adam as a consultant to us on this project, and he was very helpful in many ways on that. There were three aspects to our migration. There was an application migration. Our code had to change to some extent because of the changes in Active Fedora. Obviously, we have to migrate our content, and we chose at the same time to do a systems architecture migration to change some aspects of our system architecture. As we planned for the migration, some of the key decisions that we made were that we decided to keep our current content models. We're very interested in PCDM, but we decided not to try to switch to PCDM as part of this Fedora 3 to Fedora 4 migration. We did decide to migrate only the current versions of objects. Very, very few of our digital assets actually had intentional multiple versions, so that was not a particularly big loss. And we had our metadata in RDF data streams, as Adam talked about, and so we moved those to properties on the object. There were some what I call mismatches between Fedora 3 and Fedora 4, at least as we were using Fedora 3. Our repository had an external data stream, and there really wasn't an exact analog to that in Fedora 4. So we handled that just by moving the file location to an object property. We actually had nested RDF in one of our data streams, and that made use of blank nodes, and we never quite figured out how that would be handled in Fedora 4. So we translated that structure, kind of flattened it out into just a JSON representation and stored that as an object property. And we had been using SHA 256 as our checksum, and Fedora 4 natively uses SHA 1, so that was another transition. We used the Fedora Migrate gem, and Adam has obviously done an excellent example of describing how that works, and that helped us a tremendous amount. Most of the customizations that we needed to make to that, we were able to do using the built-in Fedora Migrate callbacks. We did do some method overrides. for example, to let Fedora 4 generate the object IDs. Since we were not a Sofia installation, we didn't have the nodes that we wanted to keep. We had the native Fedora 3 PIDs, so we needed Fedora 4 to generate new ones. And we also created rescue jobs to do each of the steps that Adam mentioned of object migration and relationship migration. We did also our own version of a post-migration validation, where we had a script that ran independently after each collection was migrated to verify that everything was there. It checked a tremendous number of things. I remember looking at some of the results and said, well, I checked this collection, and I performed 1.2 million checks. So I didn't actually write that script, but it looked at every metadata attribute. So since we had such a large repository, we couldn't really put our entire repository in read-only mode, migrate as a whole. So we decided to migrate, to lock and migrate collection by collection. We finally had all the pieces in place in May of this year. And at the time, we had 336,000 or a little more objects, 540 collections, 78,000 items, and 256,000 digital asset files. Again, at that time, about 8 or 9 terabytes. Our production migration started on May 23rd, and the migration and verification was completed by July 1st. So as I said, we were doing it, as I said, collection by collection. So there was some sort of human intervention steps there that drew it out a little bit longer, but it took about 5 weeks for us to complete the migration and verification. And so on July 1st, we are done, or are we? Actually, we decided shortly after that point for various reasons, and I'll talk about some of them, that we were not comfortable at that point on making a production switch to Fedora 4. There wasn't like there was any single one thing that caused us to make that decision, and our experience kind of evolved over time during the migration, and our understanding of what we were seeing evolved over time. If I had to categorize the things that came up that were of some concern to us and fed into this decision, I'd put them into 2 basic categories. One would be what I'll characterize as database issues, and these of course, we suspect InfiniSpan, which is part of the ModeShape 4 architecture that Fedora 4, the previous versions Fedora 4 used to be part of it. And we also had some questions about how Fedora 4 really mapped into our preservation strategy. So to the database issues, some of the things we saw and some of these I will say, no one else has ever, as far as I know, been able to reproduce. So it's entirely possible that there were factors in our local environment that accounted for these. Some I think may have been reproduced elsewhere, but they made us feel that for us the time was not quite right to pull the trigger on Fedora 4. We would see occasional object retrieval errors. We'd do an active Fedora find on something, and it would come back with an SQL error. We would immediately turn around and repeat the same operation, and it would succeed. Once when we were doing a collection fixity check, a pre-production server, we got false for several objects that upon immediate retry returned true. That, again, I suspect maybe a database latency or some kind of database issue. One thing we ran into was an issue related to versioning large collections. And this one, this is one I know that nobody else that I know of has ever been able to reproduce, but we'd have a collection with ultimately 50,000 objects. We tried to version them all, and it would fail partway through, and from that point on, no objects in that collection could be versioned. The reason I think that might be database related is that the threshold at which that happened change depending on which version of the database, of a back-end database we were using. In terms of preservation support, the other main arena, we had perhaps somewhat naively just trusted Fedora 3 as our preservation solution, and our experience with Fedora 4 led us to believe that at that point we weren't quite ready to have the same level of trust in it. Part of that is, as you probably know, the Fedora 4 data store is not interpretable without software, the actual data store. With Fedora 3, once you understand how things are put together, you can interpret them without the software, but at least I'm not aware of how that's done with Fedora 4. So this meant, I think many people do their preservation in Fedora 4 by serializing things into a format that is interpretable and basing their preservation on that. All that meant to us was that we at least needed to rethink where Fedora fit in our preservation strategy. And we now have a group on camp in the library who's working on articulating our acceptance criteria for Fedora 4 production use. And at least part of that will be a non-InfiniSpan-based version of Fedora, and we've just begun testing the release candidate for Fedora 4.7, which is a version of Fedora that does not depend on InfiniSpan. So, Julie?
Hi, I'm probably gonna. Okay, is that a little better? All right. So my name's Julie Hardesty. I'm the metadata analyst at Indiana University. And I am going to be talking, I'm not talking about, we're in the planning stages. So I'll start there. So I use in the planning stages of migrating from Fedora 3 to Fedora 4. And I'm coming at this from a purely metadata perspective here. So, I'm going to frame that right there. And I'm actually kind of focusing in on thoughts and plans in terms of structural and descriptive metadata in particular. So there might be some things that you'll get out of this and want to talk about. So right now in Fedora 3, IU manages our structural metadata in a few main ways. We've got relationships in Fedora 3, which are defined from the smallest point going up, and that's that rel ZXT data stream. And that's one direction. And then we have extra special data streams that are required to define structure at the higher level going down. So we have METS files that we use for that top, that defining that structure at that higher level going down. And that's used for images that make up a paged item, for example. And then for time-based media, we have custom sections metadata that describe that describe multiple files that make up a single object. And then we, in addition to that, we also have custom structural metadata that describes segments within a single time-based media file. So we have all of those pieces of structural metadata, and those are all XML data streams on the objects, and that connect together to go down to that digital file. So for migrating structure, my guess is that we'll be using one of the migration utilities that's out there, either the migration utils from Mike Durbin and Nick Rouet, or the Fedora Migrate Gem being worked on by Adam in Project Hydra Labs. So, and neither of these utilities are incorporating PCDM yet. So I think when we get to the point of migrating, we're going to want to make sure that we're handling PCDM somehow. So we're probably going to be trying to incorporate PCDM properties on our own in that migration. And when we're looking at time-based media, we're going to be doing that. Our instance of Avalon at IU is called Media Collections Online. And that's currently a Hydra app using Avalon, so there's probably going to be a different process that manages that migration. So we're also looking at METS and how METS might be able to be migrated into PCDM. And Christine Mayo from Boston College, she's been here discussing, she had a poster about mapping METS to PCDM, and she and I have plans to share notes on what we've been looking at. Because I've been doing some examination of METS in our repository, and what we tend to have is two basic structures. We've got one where files are grouped as a single item, such as pages in a book, and it's a single thing. But we also have another case where files are grouped into sets of documents within a single METS file. So that's like it's separate multi-page documents within a physical folder. So it's doing that representation in METS. So in looking at how to do that, how to work with that transformation, contemplating how that can go from METS into PCDM, I've been having some thoughts about making use of the identifiers that we have within METS on those different structure parts within the struct map to point to grouping and ordering that can be expressed in PCDM. So, and it's how we tend to be managing our METS, but it's probably different in different places. So I don't know that this would end up being something that could be a general way to deal with METS into PCDM. So it's probably not a single solution sort of thing. But I do think trying to work through it using those identifiers as pointers and as ways to label things in the new repository can also give us a way to verify that a METS migration into PCDM in Fedora 4 has actually worked, comparing what we have in METS with what's ended up in Fedora 4. So kind of in summary with structural metadata, so we've got structure in Fedora 3 that's expressed in those relationship data streams, but depending on how they're defined in RELZ-EXT can make a difference in how we're migrating them. We have the extra data streams that are expressing structure, such as the ones IU has placed in that top-down structure in METS, or the sections metadata for time-based media. And so we'll have to deal with those separately. There isn't a utility at this point that's managing that. And I do think it's possible to map something like METS that provides structure in a standard way, but there's some dependencies based on how we're using METS. So, and I think structure within a single file, but I mentioned that for time-based media. There doesn't seem to be any sort of option to express that really on Fedora 4 at this point, so that probably ends up being something that still has to remain as a separate file on the object for migration purposes. So the next part that I want to talk about is looking at descriptive metadata. And at IU, we are pretty much dealing with mods data streams for descriptive metadata across the board. We do sometimes have Dublin core, but that's in addition to mods. So if we have Dublin core, we also still have mods. The migration utilities that are available right now don't do any translation of mods into RDF. They're bringing those over. They're bringing the mods over as XML data streams over as a file. So you end up with the binary or non-RDF resource that's the mods XML. There's a mods RDF ontology that's available, but it creates complex hierarchical RDF. And from what I've seen at this point, it doesn't seem to me to be worth it to deal with managing that in the Fedora 4 repository. It ends up creating new objects in the repo, and those objects don't really represent any digital content, so I think that ends up being difficult to manage over time. I don't think we have the need to reflect this legacy mods in RDF so that we can get, for example, mods XML back out. And moving forward, I think that we're going to be dealing with description of our objects in our repository just in a different way in RDF than what we would have working in XML. So XML, where you're dealing with something that was more of a cataloging-centric sort of thing, describing things in RDF, is going to be more meaning-centric. I'm still trying to figure out how best to explain this. It's kind of in my head, but I don't really have it expressible yet. But it's more like what it is and how it relates to other things out there is what we're going to be doing for description going forward versus what it looks like. And I don't know if looks like is really the words that I'm wanting to use, but there's a difference there, I think. So going from mods and XML to RDF statements is going to mean mixing and matching of ontologies to keep the information expressed as simple statements on the object itself. That's the goal that I'm going to have for this. And we don't have a one-to-one transformation of mods metadata that's going to work directly on the object in Fedora 4. I'm pretty sure that we're going to encounter things in mods XML that we're just not going to be able to figure out how we want to express that in RDF. So I am trying to calculate how best to set things up so the content that we have is still usable after it's migrated. So that's meaning, to me, considering what's really needed on objects in Fedora. So we want to know what an object is and what we need to index for searching purposes, discovery purposes, what information might be needed in an external triple store for indexing and discovering in an end user interface. And then how we want to present a full item view, what all the information is that we have about something. So for us at IU, I think that means our migration is not going to drop the original descriptive metadata in XML. I think we're going to continue with that, bring that mods XML file over with us. And I'm guessing that we will more than likely not be replicating every single element that we have in mods as RDF properties on the Fedora object. We're probably going to be shrinking down what we have for the most part in our mods XML when we express it as RDF. So I think we also have to consider what we might want to include in an external triple store, especially if we are interested in reconciling any of our mods XML into linked data RDF. So I think it's, like I was saying, I think it looks like our descriptive metadata is just going to be different after we've migrated. So we're going to have different ontologies, we're going to have different values, we're going to be looking at having URIs instead of strings of text, which is what we have in mods XML at this point. And we also need to keep in mind that what descriptive metadata for a migrated item is going to look like in comparison to a similar type of newly created item moving forward. When a new item is created in Fedora 4, what is the descriptive information that we're going to be putting onto that? Is it going to be different or more than what we were going to be able to migrate over from Fedora 3? And then time-based media items are, I think, different for us in migration terms, because those are being handled for us right now using Avalon. And Avalon is a Hydra-based application already, but it's in Fedora 3, what we have right now. So going from Fedora 3 to Fedora 4 for Avalon is going to be more about how Avalon is going to be managing Fedora 3 to Fedora 4 move, which is being worked on right now. But we'll have the same considerations for structural and descriptive metadata there, but I think they're going to be managed differently than what we'd be doing with our other Fedora 3 instance, and it'll be managed more with a migration within a Hydra environment, so that'll also be different for us. So those are metadata things that I've been thinking about, and I think Mike's coming up next.
So hi, my name is Mike Frisha. I'm from Yale University, and I manage the Digital Library Programming Department. And I have to say, I really like these Fedora 3 to 4 migration panels. This is my 4th one in 2 years, where I presented yet another half-baked plan for Yale to migrate. So I hope this one's a little more baked than the others. A common theme between all of the plans that we've had is that we're looking at a greenfield approach. We aren't seeing this as an upgrade project. We're not really even looking at it as necessarily a migration project. So, I've tried to kind of think of what questions we have to ask ourselves and what are the real barriers. And so one of the problems that I see is that attempting to plan this kind of upgrade migration, whatever you want to call it, while we're continuing to grow our current repository is kind of unrealistic, but also trying to plan this at a time when we're not growing the repository is also not realistic. So how we manage the content during this whole process is kind of complicated. What I've tried to architect is a system where we can ingest into the current, what's becoming our legacy system, and into a new system concurrently, and then also trying to figure out how to handle that potential space problem. So right now we're looking at about more than 100 terabytes of digital content. So if we were to replicate that entire 100 terabytes, and maybe by the time we actually start doing this, we'll be closer to 200 terabytes, to have all of that content replicated just isn't realistic and also just not financially responsible. So the other aspect of that is also thinking about what that means for a migration. We're looking at about 35 million files in there to move from one system to another. We would have to thoroughly audit to make sure that all of these files did move intact. So again, I kind of don't see this as an upgrade. I don't see it as a migration. I almost see it as starting over, but I don't really see it that way because I think we've learned a lot to get to where we are now. So some of the questions that we've started to ask ourselves is when we're going to implement this new system and we use RDF for metadata, what does that mean? And so one of the exercises we took last spring was to poll the community and kind of have some conversations with different people who have done this or thought about it and tell us what an RDF migration actually means and what we could expect to gain as a result of it. because when we were looking at it, we started to question whether we even needed RDF. And I think that was a question that was difficult for us to answer, because at the end of the day, Solr was going to store basically a flat XML version of our metadata. If that's all we needed, then what do we need this RDF stuff for? But I think the conversations that we had were great, because it kind of sold us on the idea that it's not what we gain right now, it's what we will gain in the future. The other question is PCDM. Obviously, we're going to use it, but what is our content going to be modeled in that like? You know, we really had to review what types of content we've ingested, what content we haven't ingested but want to, but then also think, what will our models look like? And is the community going to have some standardized models that we can use by the time we get to the point of migration, which it seems like it's moving that way. The biggest question from our current Hydra, which I'm calling our legacy system, what features do we want to keep, and what features are we going to leave behind? It's a difficult question to ask, because you can go into this sort of thing thinking you need everything that you did before, but maybe you don't, and it's worth asking. The other question that I've been asking my team specifically, is there a way that we can do this in a way that we more closely align ourselves with the Hydra community going forward? I would say that we are really far from the core Hydra code. I mean, I would say that we're almost barely Hydra. We use the Hydra framework in that we have Fedora, Solr, and Blacklight, but we're on Hydra Head 5. So it's not, you know, we haven't really done our part in advancing that part in the Hydra community, but I think we could, going forward, do things much differently. Then other questions, what about external triple stores? What is the benefit there? Do we need that? Is there an advantage or even a really good, compelling reason for us to have a publicly accessible Sparkle interface into our RDF triple stores? And then I think the most important question that I'm starting to ask now is, who are we not including in the conversations to do this work? I think initially it was perceived as being an IT problem to solve, and as I'm starting to go through these questions, I'm realizing that the IT component is very small. As far as our future, so I do have somewhat of a half-baked plan, and the way that I see it is us answering the question, how do we more closely align ourselves with the Hydra community, is maybe it's Hydra in a box or Snappy Turtle, which I definitely like more. And that would be a major change for me to transform my team to start to contribute to the core code base and then have Yale adopt what's been put into the main repository, rather than us go off on a path where we upgrade to Fedora 4, we have our new Hydra stack, and then we just extensively customize it to the point where we can't upgrade again. Because we know that Fedora 5 is going to happen. So what's that migration going to look like? And if we kind of like branch and fork ourselves too far away, then we just won't be able to sustain this going forward anymore. So that's about all I have. I was really hoping to come up here and present success, but at this point I think our version of success is that we've come up with a solid plan for our migration to Fedora 4.
So we have some time for questions now, and we'd be happy, any of us would be happy to answer any questions you might have, or if you have experiences migrating from Fedora 3 to Fedora 4, happy for you to share those with the group as well. Are there questions?
I'm just getting the microphone so we can pass it around, I think.
So you're from Tufts and you're using Fedora Migrate. You had said you had about 11 different objects and you're going to curation concerns. Are you using PCDM? Sure. Okay, so when I wrote the gem, PCDM wasn't out yet, and then Ben Armenter, subsequently, Ben Armenter picked it up about a year later and tried to make it do PCDM and ran into a lot of problems. Right. Right. So what you're having to do is you're having to monkey patch my code, which is totally fine. Yeah. I tried to architect this, and like this is kind of speaks to the Hydra way. You do something, and you want to make it available to the community. I tried to the best of my ability to make it somewhat customizable, but I think where it falls down is when you get into this situation with PCDM. So the one thing I wanted to mention is that our effort to go from Fedora 4 to Fedora 4 PCDM, which is essentially now Sofia 6 latest to Sofia 7.2, that effort we're doing in Sofia proper, so it is not a gem. So if you could, for example, follow our path, which would be go from Sofia 5 to Sofia 6 using Fedora Migrate, and forget about PCDM for the time being. Then use Sofia's tools to go from Sofia 6 to Sofia 7, right? In other words, you do it in two hops as opposed to one big hop. But if you want to do one big hop, like you're talking about, because you're just talking about curation concerns. Yeah. However, if you're using Sofia, you're also using curation concerns. So you could theoretically use a Sofia application and do your migration to curation concerns. You would just have to identify if you had one principal work type that you were using. If you don't, then you could probably just stick with curation concerns. As a side note, I would encourage you to come to the architecture breakout tomorrow morning at 11:10 here, because we're talking about merging those two, and it's important that we hear voices from curation concerns, because I don't think we've heard them before. Respect to that. So that's unrelated to migration. So I just wanted to mention a thing about Sofia, and that Fedora Migrate is currently not adequate, at least as it's written, to handle the PCDM, to go Fedora 3 to Fedora 4 plus PCDM without a lot of monkey patching and standing on your head. So.
Are there other questions or stories about migration or comments?
Hi, I'm Josh Westgard from the University of Maryland. This is really just a comment from our perspective for Mike, really. The usage of the triple store, we view that as most useful for what we call admin users. So we envision it as admin users, staff users, and then the public. And the staff and the public are mainly going to be going through Solar, but we see a use for the triple store for admins. So that's just our view.
So it sounds like, and maybe this is Adam and Jim to some degree as well, that there's obviously been use of Fedora Migrate to perform migrations and customizations thereof. It sounds like something along those lines has been built into Sofia. So it'd be interesting maybe to hear a little bit about what that tooling is envisioned to look like. And I guess the question is, so you described sort of a two-hop process, but what the question is, what makes the most sense for the community in terms of tooling to facilitate migrations, because it seems like there are kind of maybe two things right now, and to what degree it can be generalized, to what degree it still is going to require significant customization. I'm just sort of thinking about a plan for tooling to help people approach this, basically. Here's a microphone, Adam.
Right, so as it is with the community, what happens is somebody is tasked with doing it and then does it, and then other people try to use it. So it's sort of like a pile-on chaotic effort. And then what emerges out of this chaos, sort of like the origins of the universe, is there's this sort of this slow gravitational condensing of effort and emerges some tools, right? So we had this jump from Fedora 3, and there was a kind of a double whammy here, because we had Fedora 3 to Fedora 4, which is a big jump, and then you had PCDM, which coming right on the heels of Fedora 4. So if we didn't have any PCDM, we'd kind of be like, well, Fedora migrate, okay, and let's focus on that. So now we have PCDM, and our approach at Penn State to do it within Sofia has been to replicate the same process that we did in Fedora Migrate, but do it in the Sofia repository as opposed to the Fedora Migrate repository. So Sofia 6 will have an export function that exports all the content out in the form of these JSON files, similar to what I did in Fedora Migrate. And then Sofia 7.2, well, it would be 2.x or 7.3, to be released, would have the import functions to then import this data and recreate it again in Fedora 4. So that's the plan. It hasn't been written yet. We hope we got the export functions, I think, done. My colleague Carolyn Cole's worked on that, and I think she's begun to do the import. But as Sofia, because Sofia 7 has been really actively going, we were waiting for a proper time to kind of, focus on that release and then get it working. And then, of course, Sofia 7 will continue to evolve as it needs to evolve towards Hydra in a box, essentially. So then once, and again, this is all very pen and paper right now, that Sofia 7.2 is released. We focus our import efforts to do the PCDM migration. So this would be Fedora 4 to essentially Fedora 4.7 using PCDM models. So let's say Sofia development continues, so you got Sofia 7.4, 7.5, et cetera, maybe even 8, I don't know. There's been no talk of 8. I don't want to scare anybody, but it could, it could happen. And then we would take then that code and merge it back into the branch, so it would be there for you to migrate if you wanted to wait till a year from now, maybe. And at some point if there was a later version of 7 or even 8, that code would be there for you to export your data out of 6 and into 7 or later versions. But that's all on paper.
I got a question. Is anyone in the room migrating right now? Anyone? Yeah, we've already discussed. Yeah. Migration in a year. Oh, IU. We're doing that. Okay. Nice. It's good to know. Yeah. Get those plans made.
my exercise today.
So we don't have specific plans or concrete plans, but one thing we've talked about is in our repository to actually stand up a new Fedora 4 repository, and in our current Fedora 3 we have basically an API layer, and what we would do is make the APIs be able to talk to Fedora 3 and Fedora 4, stand up the new Fedora 4 and start new content going into that, and then at some point, theoretically, our Fedora 3 content will be moved over to Fedora 4. Our repository isn't more than 100 terabytes, but it is roughly 26 terabytes. And with all the code and everything that's written around Fedora 3 and the time it would take to migrate that content and also to build up the ecosystem for Fedora 4, it's a significant thing. And so we may do sort of both systems live at the same time and gradually move content over. Something we've thought about, but we don't really know yet.
Anybody else while I'm up here? You just want me to. Sorry.
So you had mentioned in Fedora 4.7 that they're replacing InfiniSpan, but I wasn't sure what actually replaces InfiniSpan in the stack.
So there's, in the Fedora stack, there's the storage layer, which is mode shape. And in Fedora versions prior to 4.7, it's mode shape version 4. And 4.7 replaces mode shape 4 with mode shape 5. And mode shape 5 does not use InfiniSpan. So it's mode shape that uses InfiniSpan, and when you go to mode shape 5, there's no more InfiniSpan. So there is, if you're currently, if you have production data in 4.6 or earlier, when you upgrade to 4.7, you'll need to export your data from Fedora and import it. But this is an import-export process that's totally internal to Fedora. And as Andrew has described it, you just simply make one call to an endpoint, it dumps out your data, and then out of Fedora 6, and then you spin up your Fedora 4.7 instance, and you say import, and give it the location, and it just sucks it back in again. So it's a very simple process. But I would add that what we're doing is, because we're going to wait till 4.7 comes out, because then we just do all of that at once. We go from 4.0 to 4.7 and the PCDM and all at once kind of thing. So if it doesn't sound like any of you are, but if like you're really burning to migrate right now, if you could hold off like, 3 weeks, 2 weeks, 4.7 will be out, and then you won't have to worry about it. Yeah.
And I will add that that was one of the things that factored into our decision that we were going to hold off on doing our production cutover to Fedora 4, is the realization that with the post 4.6 version of Fedora, that would require this export and re-import, and so that seemed another reason to say, let's just put our production cutover, our migration on hold, and wait for Fedora for the post InfiniSpan version.
This is either a question or a comment, but the talking about dumping data out and re-importing it is a pretty significant thing to do when you've got 100 plus terabytes of data. And we don't, but I know Yale does. And I think it's fairly significant for us with roughly 26 or so, depending on how long that process takes to dump it out and to re-import it, plus the storage requirements if you're gonna at least double the amount of storage you need all of a sudden. those are pretty significant questions. So for for us, thinking about migrating to Fedora 4 is a pretty big project, and it's a pretty significant thing to plan for, and we haven't really made concrete plans. But it kind of feels sometimes like it's like things are developed with the idea that you can just dump out the data and re-import it, no problem, which is not necessarily the case. So for what that's worth.
Yeah, 100 terabytes. Sure, no problem. Dump it out. And no, that's not easy. And but the reason why is that the layers on which Fedora 4 is built are moving. So what were we going to do? So yeah, it's a good point to make, and I don't really. There's no good solution to it if you don't have an extra 100 terabytes lying around. Yeah.
I could offer that. I've been thinking a lot about how to do this in a way that we don't have to replicate the entire stack, but it starts with a complete audit of what we have in there. And so when we think of the content where a TIFF image came in, and as part of that, we also had a JPEG and a JP2. So we want to audit every single one of those to make sure that we in fact do have a JPEG and a JP2, and if we don't, we want to put those in place. Then what we would look at, because our current Hydra stack doesn't make use of the TIFF or the JP2, we would probably start by migrating just the JPEG images into the new system. And then we could also then migrate a JP2 and then eliminate the JP2 once we audit that it did in fact make it intact, and then do the same thing with the TIFF image. If we were to do that in a very structured and scheduled way, and we were to run our audits, say, once a week, then we would probably not be replicating any more than maybe 1 terabyte at a time. It could be a very long process, but I think to get the new system up and running quickly by bringing all of those JPEG images in, we could probably do 100 terabytes of content in less than 30 days. Now we would have 2 usable systems. The new system won't have the JP2 or the TIFF image that it would utilize, and those would have to come in slowly. But it's kind of setting a pace that's a little slow, but very deliberate. And that's, to me, the way to make it work.
Yeah, I think we're just about out of time.
Just one quick follow-up to the storage. I want to highlight what the Hydra Dam's 2 folks are doing with asynchronous storage, where in Fedora, where you have a binary, it's actually a redirect that points to where the file is located. So you could theoretically utilize that solution to point to where your data is and leave it there. So future migrations, no matter what system you were going to, you wouldn't actually move the data, you would just simply move the pointers. But again, it's more of that's where you start to ask the questions, what does a migration mean? It's not just a simple dump and import. It's actually starting to re-envision how we're actually storing our information, because yeah, you have 100 terabytes now, you'll probably have more later. Right? Yeah.
So there are a couple different things going on in sort of related conversations. One, I would argue the most significant conversation is around what are the responsibilities of Fedora, how does that get codified in a specification and an API? Like that's sort of the contract of what a Fedora repository does. And then there are conversations around, well, what does that? You know, what's the code that actually fulfills those contracts? And so for this mode shape thing that's changing with 4.7, it so happens that there is a simple way to upgrade your content from one version of mode shape to another. And that's just sort of this dump and reload that's completely dependent and tied to the underlying code that's there, the mode shape stuff. So mode shape offers this, and it's easy to use and it works. You just do it, if you can just do it, right? If you have 100 terabytes, maybe you just can't do it. But that's sort of one part of the conversation. The other part of the conversation is With the API specification of Fedora, that's defining the contract of services that Fedora offers. And so something you may have heard of that's going on is this notion of import-export at the Fedora level. So one of the principles of Fedora is trying to make it as easy as possible to get your stuff into Fedora in a standardized way, RDF and files, and to get your stuff out of Fedora as easily as possible. And that's where import-export comes in, because it is a utility that interacts with the contract. It interacts with the API of Fedora, independent of what implementation is underneath that API. So for the slightly longer term, not that far out, since the import-export is being built right now, it's very conceivable that the migration would, you would be able to partition it however you want to, using sort of import-export capabilities along the API versus like a full effective database dump and restore. So just noting that the suggestion right now for moving from one version, the specific version of Mochape 4 to Mochape 5, Fedora whatever to Fedora 7, it's saying, well, like there's something there based on the implementation. You can just use it, it'll just work, but it won't just work for everyone, and in which case it argues for tooling that works against the specification. So just some points to throw into the mix.
I appreciate your attention and your participation. I think we need to call it quits on this right now so that we're fair to the group, the presentation that comes after us. And maybe at Hydra Connect next year we'll have a whole bunch of whole bunch of successful migration stories. Thank you all.
All right, we'll go ahead and get started because the first little bit is sort of just setup and preamble, and so if people walk in, that'll be fine. I'm Mark Bussey. I care enough to do the very best, so here's my text document for my presentation. This is basically the outline that I've posted to the wiki if you want to follow along what I'm going to be doing, but mostly I'm going to try and do a live walkthrough of a Sofia system. And I've also just turned on my screen capture, so if everything goes right, I'll have a copy of the audio and the screen synchronized when we're all done with this, and I'll post that up as well. But there are no slides yet. We're not done. It's live. Just to level set, in recent discussions, I realized that I picked perhaps one of the most ambiguous words that I could for the title. So when I said a walkthrough of the Hydra stack, it is really sort of showing how things work, but what I'm really aiming to do is show what things look like in a UI to our users, what things get persisted in Fedora and what's stored, and what things our developers are working with. So I'm going to go through in a vanilla installation of Sofia and create some data, create some works, create some collections, and sort of show them both what they look like in the front end and the back end and how we interact with them in code. And I found this just, again, this was a disclaimer I put on my presentation on Monday. I actually don't pretend to be the expert on this, and I have been asking friends in the room questions as I've been preparing for this presentation. But this is an activity that I've gone through that sort of helped me put the pieces of how does PCADM work together, where's the metadata, what does RDF look like, all of these things. I'll have question and answer at the end, but there's also lots of people in this building who are way smart about all this stuff, and as you see details and bits and pieces, ask lots of questions. This is by no means complete or exhaustive what I'm going to manage to do today. So the context is, what I'm going to show is a vanilla installation of Sofia 7.2 installed. So here's the GitHub repo. That's an awesome logo. We just made that last week. But I'm just following the instructions in the README that said, create a Sofia-based app. I've done all this at home as homework so that you don't have to see me generate a Rails app and do bundle install, but this is what I'm running. There's no special magic here. And so I'm starting out, so I've got a Sofia up and running in a virtual machine on my system. And you will probably never see this in the wild. This is a completely empty repository. If I go to Fedora, I was actually even shocked by what I saw. Because if I go to the main Fedora landing, I have a REST endpoint and I have no children. There is nothing in my Fedora. It is empty, empty, empty. And just to prove that, from my other view, where did this go? Let's just see what Active Fedora thinks is here. Does that work? That works. There are 0 Active Fedora things in here. We'll go from here. Is this font okay for everyone to see and read as I'm talking? And am I loud enough? Okay. So, and what I'm actually going to be looking at is the works and the collections that I'm building. So we'll just, I have 0 works in my repository from the console. And I have 0 collections. So if I go back to Sofia, again, I've created myself a user on this system, so I'm logged in as me. That's just the self-sub sign up. So I'm going to go to my dashboard. And I have been using this, but I've wiped out my Fedora, so you'll see some user activity. But there really is nothing here. So I'm going to start by creating a new work. Oh. may need some help from the audience here if I didn't clean this out right. This is definitely audience participation. There. All right, sorry about that. I didn't clean up after myself. So empty repository, I've created a user account for my system, for myself. I've gone to my own dashboard. I've said, I want to contribute to work. You'll notice that using Sofia, there's some required fields. So title, creator, need additional fields. Why did I not get something still not quite happy? Let me do this one more time. Try starting my server one more time. So there's a little bit of JavaScript in Sofia that looks to see if I have all that required metadata filled out. It's not ticking the checkbox that tells me that it's all complete, and it's not going to therefore enable my button that lets me submit my work. I'm saying that out loud because it's possible that one of my friends in the room knows why that's happening. That thing on my title. Caps lock, I think. No. Oh, that's LastPass wanting to fill in my password for me. I won't do that. It's giving me save. Okay. Something's not quite how I expect, but. So I'm going to start by doing sort of the simplest case, which is uploading an image. So a single file. Actually, I'm going to keep it private for now. Did it not just? There's LastPass trying to fill in my password for me. There we go. So I was waiting for that little guy. There's some other JavaScript that's going on this page. So fill out the required metadata, choose some files, folders. Choose my file, it uploads my file. All right, so I have an image uploaded, I have a little descriptive metadata. I'm going to go back to Fedora. Right, I haven't hit save yet. Or did it? Ooh, it created some stuff for me. We'll ignore this a little bit. That's from that not firing quite right. But I'm going to go ahead. I've added files. I've entered my required metadata. I'm going to leave it private. Oh, I better agree to the deposit agreement. Now I can save it. Sofia kindly tells me that there's some background activity going on. So I've uploaded a file. It's going to run it through a characterization. It's going to create any derivatives it needs to. It's going to look at what I said I wanted the access to be and set the access to the level that I set. In the meantime, it's going to choose the most restrictive possible and set it to private. By the time I've said all that, all of that work is done. The derivative has been generated, the file's been characterized, and the access has been set, though I left it at private. So again, this was the baseline before I deposited this. Let me refresh. So before 4 children, now 8 children. Some things have happened. One of the things I want you to notice is that I've created a new work. It's gotten assigned a Noid. It turns out that that's actually the way that I can identify that object across the console and across Fedora. So if I go look in Fedora, I have to pay more attention, 5, 6, 7. Here's a thing that has that same Noid. If I look at that with any luck, there's my sample work for the demo. We'll go into the metadata in a minute. I'm going to go back to the demo. I actually attached a file to this work. So again, Sofia 7 now has the notion of complex works. So the work is the containing metadata and description of the entire work, which might be 1 or more files. And so there's a set of files which themselves might have various kinds of metadata. So I want to look at that attached file. Just to show that I can get it back out. Oh, you're going to do this a little different. But there's my image. You can figure out why I chose it. But as I mentioned, that characterization had been run, so you'll see that Sofia has determined how wide, how deep my image is, what format it was, that it was a TIFF. But most notably, I'm looking for this ID, another Noid, 405. If I go back into Fedora and look for 405, I find my file, hydra.tiff. I will look, if I notice down below in my file types, I'll notice that from a PCDM standpoint, this is an object. So PCDM, there was a conversation earlier today about PCDM doesn't really have a notion of file sets. That's something that Hydra adds in. And then from a Hydra standpoint, this is a file set, which means that I might have multiple sort of related files attached here, usually derivatives of one another. I'm going to go back and look at my main work. Actually, I'm going to go look at it in the console as well. So I'm going to look up a work. Work.find. And again, I can use that Noid. And I get something back. And I can look at the title. And it's the sample work for the demo, so that makes me pretty sure that I found the right thing. I also know there's only one thing, so. But I can look at the depositor. I can look at the creator. Now you notice that I didn't actually set the depositor. I logged into the system. The depositor is the system tracking the user who did the action. The creator is the metadata that I described as description. And then I did set this to be attribution. Let's see what that looks like. Which is actually called rights in the code. And you'll see the first sort of bit of linked data sneak its way in. So in the UI that end users see, I'm using the label, the preferred label for the resource that I'm pointing to. The resource that I'm pointing to is the actual URI for the Creative Commons license that I chose. So the first question that was, how do I figure out, because these aren't called exactly the same things. So in the UI, we call it rights and keyword. What is it? W dot. We do use keyword across. So code and the UI are pretty well aligned, but when I look in Fedora, I have a creator that's marked bussy. I have a relation that's etching, and that relation is namespace DC. So probably, if I look over here at my namespaces, I'm checking whether this is DC11 or DC20. If anybody in the audience knows the answer, shout out. Elements 1.1, so DC is. So I've used a predicate in my internal Fedora storage that's different than what I'm seeing in the console or the UI. That's part of the magic that Hydra is managing for me, so I don't need to know that once I set that up initially. The model, again, I've set this up to just manage generic work, so everything is called a work. Here's my rights assertion. It's Creative Commons, it's a rights, and namespace 2 is Perl DC terms. So here's DC terms rather than elements. Here's my title, also out of DC. Here's my depositor, a different namespace, a different predicate. So again, all of those things are getting persisted in Fedora. They're all showing up as different, possibly things. So it's called DPT in Fedora. I called it as depositor. How do I figure out what those are? So part of curation concerns building on the stack of PCDM and Hydra Works is that curation concerns, when I generate an application based on that, which Sofia then uses, includes a piece of code called basic metadata. Basic metadata says, here's the things that by default we're going to give you in a curation concerns or Sofia app. And we'll see creator predicated against DC terms or DC elements creator. Let's see if I can rights as DC terms rights. Depositor actually shows up in an even lower level. So there's only about 3 pieces of really critical metadata. So the depositor, And I think the access, the visibility gets stored at an even lower level than this. But this code controls what I interact with in the console and how that gets translated to and from Fedora. And then once it goes back into my application, the application and the internationalization controls what I see in the UI. So remember that I deposited this and said I was going to leave it private for now. I want to take a look at the access controls. So again, I'm looking at the actual object representing my work in Fedora. One of the node attributes is access control. If I look at that access control, it links me to another node. It lets me coordinate multiple access controls between multiple works, but I think this is the place where I will see what I want. Yes, and it says that it grants access to, and if you remember the URI that I plugged in to get the initial work, this is actually that initial work. So this access control points at that work. It says that the agent, which is identified by my login ID, which is another URI, so Mark Bussey has write access to this object. And there's so there's that single access control on this file. If I go back and I edit the object, I think it will be share, and I change it to institutional. And I refresh my work. Thank you. That's the problem with me going off script. Didn't say that in step follow-up. Really? Here's my two access controls. So we already looked at, I think, this one. Oh, no, so these nodes may not be ordered. There's a change in RDF, the RDF gem that's included in Sofia that actually matches the spec. There's no guarantee at this point that these nodes come back ordered. Something to be aware of, because all of the Hydra systems prior to this that we're used to working with probably did, and we got used to that and we're a bit lazy. But here's the access control, because I remember this hash not. But this is the one that grants Mark write access. But remember, I just went back and added one that granted the institution, which is really the people who can log into this system is what institution translates to. So I'll see that there's a group is the agent for this. It still points at the same object, but that group has read access. So that's me making this now readable by the institution in addition to readable and writable by Mark. Oh. So part of what I'm trying to show is you've noticed I've just been clicking through links. All of this is linked. All of this is expressed as linked data. All of this is serializable in RDF. So the things that I learn about structuring objects are true for how I interact with access controls, are true for how I look at the relationships as we get into collections to objects. All of those use the same framework and the same kind of coding. That's tremendously powerful in that once I start to learn how these concepts work, they apply at every scale of the stack and every scale of the models. So I want to go back to my main work, which I can actually go to because I know which one this is granting access to. There's back at my sample work. I want to point out that the works node is 3B59185567, but that it has a related image 5X21TF405. So let's look at that for a minute. Oh. And lo and behold, that's Hydra TIFF. So the work is separate from the file, but because I uploaded this file as the first file, again, there's a convention in Sofia that the first thing I upload should become the representative for that work. So because the first thing I uploaded was an image, I get the nice thumbnail. If I had uploaded a text file, which I'll do next, I won't get anything as a representative because there's no convention right now in Sofia for how I render a text file. But if I look at that TIFF file, the creator this time, so rather than the depositor, the creator is actually assigned to my system ID, so that's a system choice. But again, I'll see that the original name was hydra.tiff. That shows up slightly differently in the UI. So it just shows the file name, the original file name, as the label. But as I go down, see the depositor. Okay, so the metadata, so I'm looking now at a file set container. I'm going to gloss over file sets versus files, and I'm going to drill down to the file and look at the actual file. So this contains yet another thing. This other thing contains yet more things. There's a lot of nesting of containers. This is my actual file. So the original file name was hydra.tiff. It has an image type of image tiff. So there's where this little bit of metadata is coming from. I'm hoping that there's a height and a width. You'll notice here that we're jumping namespaces and pulling this out of EBU core instead of Dublin core. Again, choices made back in that, actually not, so choices made in a metadata definition file. Because I'm looking at an image, that's actually some of the behaviors around particular file types, images, documents, media, and two more that I'm going to forget right now, are provided by Hydra Works and Hydra Derivatives. So in the same way that the basic metadata was provided in curation concerns, I can hop over and I can look at the schema for an image in Hydra Works, and I'll see that an image has a height and a width, and it might have quite a number of other attributes that we won't look at right now, but all of those are coming out of Hydra Works. Any of those are overridable at any higher level in my application stack, so if Sofia wanted to call this picture size and picture height, it could overwrite these if it chose, but by default, you'll pull these in because these are lower level gems in the stack. The reason that, so that basic is nice because I can assume that everything in my repository has basic metadata. So it will all have the option to have a title, it will all have the option to have a creator, it will all have some dates. It wouldn't make sense for me to give everything in my repository a width. If I had an audio file, width probably wouldn't make sense. There are other kinds of metadata that make sense for other things. So for instance, if I looked at the schema for a document, I get things that seem more document-like. Page count, what language it's in, word count, character count, line count, whether there's any kind of markup used in it, paragraph count. So as I say, by default, we've got audio, document, image, and video are the things that are currently just sort of out of the box you get in Hydra Works Curation Concerns Sofia. So I want to go back and look at all of that in my console and see what the correlates are. So I've already looked up the work. So again, the work.title. So I want to see if the work contains anything, and that's the members of the work. And I have an array of stuff, and it actually only looks like one, so I'll look at the first one. And the first one is a file set. So I'll look at the files in that. And there's a Hydra PCDM file attached to that. So I'm just going to assign that so that I don't have to keep typing that long thing. And I'm going to, again, that's an array because there might be more than one. Excuse me. So I'm now looking at the first file in the file set that's attached to my work. So f.filename. So I'm now looking at the thing that is called HydraTIFF. Again, we figured out that that had a MIME type. Because I know it has that kind of MIME type, I know it gets stored as a work type of an image, so I know that it has that image metadata, so I can start asking in the console about those same attributes. So the thing here that I want to point out is that, again, I don't have to know anything about the predicate mappings, about the persistence, about how all of this gets stored. I just know that I'm looking at a file. I know it has a file name. I know it has some metadata. The metadata is described. I can dig through the code and figure out which fields are available to me. All of the technical metadata is getting populated by a characterization run through fits. So I have all of these things happening for me very nicely without a whole lot of thought. In fact, I can even ask it what version of fits was used to characterize this particular file if I happen to have a repository that has contents over quite a length of time. If I know that fits is started changing the kind of output it gives or gives me more or better output, I could go through and query my repository and say all the things that were characterized by older versions of fits I want to recharacterize. Again, that's sort of nice because I would not necessarily have guessed, unless I had prepped for this demo last night, that fits version is actually premise has creating application version, is where is the predicate that the team chose to store the fits version in. So I wouldn't necessarily know that, except that I know that that's the fits version that's running. So when I see 10.2, I'm like, ah. And then when I go to the console, I confirmed that because I'm able to see that it says actually fits version. And if I went back and looked at probably the base metadata in Hydra Works, it would show me that mapping. But again, on a day-to-day basis, once I start writing code for the application, I stop thinking about those predicate mappings. Just to prove that this is actually a file, I can actually even request the content. Isn't that beautiful? And so, so we can actually look at, see if I can find it quickly. HydraWorks characterization. Oh, there it is. All right. Questions about works and files? All right. Now I'm going to go and actually show the sort of more interesting piece of PCDM and show how objects relate to one another. So I'm going to start by creating a collection. Yes? Where is so that file, and someone correct me if I'm lying, is actually, so the original is actually stored in Fedora and persisted in Fedora. And any derivatives that I might need, like the thumbnail, are probably created offline in a temp directory in the application. But it is actually stored in the Fedora repository, so not in a database, but in Fedora 4 as a non-RDF resource. So everything that we've been looking at so far is an RDF resource, and so it's a graph of RDF nodes. And then there's a node that says, here's a thing that's a non-RDF resource that actually has a checksum right here. So, and that's what my download link is here actually. So all the other pages we've looked at haven't actually had this download content. This is the actual file that got stored all the way down the stack into Fedora. So if I choose download content, I did this from the application, but now I'm doing this straight out of Fedora. So last time I did that, that was mediated from all those gems, asking down and asking into Fedora to back through all the gems, back through Sofia and through the UI. This time I'm just asking straight from Fedora because I know how to find it. So let's go back to my dashboard. And let's create a collection. I'll choose the tremendously original name. And I didn't call it out, it's more a Sofia thing than anything else, but both at the work level and at the collection level, Sofia gives me the ability to add additional metadata, so description and other things. I'll add a description actually after we create this, but does not require that for me to create the objects. So not a whole lot to create a collection. What's the name of the collection and who should be able to see it? I'm going to let it be public. Again, I get a collection, there's nothing in it. The Noid is TM70MV16Z. If I go back to the root of my Fedora in my development environment, there's a new, now I have 11 nodes rather than the 8 I previously had. And one of those has that Noid of the collection. I'm starting with an empty repository so I can see this list of things, and I've gotten good at practicing at seeing the Noids back and forth. In a real repository that had more than 100 objects, so I couldn't see them all on this screen, or even one that had more than 12 because I get bad at finding things, the real way that I would find that would be the other way around and go to the console. So I can look for a collection. By the Noid. So just to prove that it's my collection. But I can also ask in the console, I can ask the application for the URI. And this URL is the URI that I'm using to access. That's the same thing that was here when I linked it from the list. So I'm shortcutting for the demo by just looking for these in the list, but it really, if I had a fully populated repository, I would need to use the software to resolve the Noid to the full URI. So again, collection, the title by default in Fedora uses the convention that DC title will be what it will show as the title. If the thing doesn't have a DC title, it just shows the URI in this field, in this part of the display. It's also repeated here in the actual layout of the metadata. The depositor, again, is Mark, because I was logged in as this. It doesn't track who created a collection because it's an aggregate, and so one person might be inaccurate to describe it that way. The access control, because I made it public, has 2 access controls. So one of these, again, is going to be that world can read. So the group public can read. And one of them is going to be that the depositor can write to it. So the depositor market curation experts has write access to this. But not too much other metadata right now. I'll make the access control. It has a model, so I know that it's a collection. Again, if I look down here, from a PCDM perspective, the model is a collection, and from the HydraWorks or curation concerns perspective, it's a collection. So like I said, I want to go back and I want to edit this, and I want to add a little bit of metadata. sadly not very creative at making up metadata for collections. I'm going to say the collection type is images. Oh, and I can actually here, I bet I could give it a so we'll give it a publisher, and I chose a file type of image, and I gave it a description. And I'm going to update my collection, and if I go back and refresh, I should now have a type that I added. I should have a description, and I should have a publisher. So I didn't look and prove that I didn't have those things, but I'm going to refresh that from Fedora since I made changes. And you can see my publisher changes through. Right now, my collection is empty. So I want to go through and assign a work to a collection and see what that looks like in Fedora. AdWorks. Not a lot of choice. Oh, add to collection. I can create a new collection, or I can update an existing collection. I'm going to update my existing collection. So again, this is before I refreshed my collection from when we looked at it before. The number of children, 0. I don't see any reference to members. I'm going to refresh it. I now have a child. I now have contains, and children escaped me on this screen, but it should say 1, number of children 1. So if I go look at the members contained in this collection, I have a bunch of proxies because we wanted to avoid the requirement that a work can live only in one collection. There's an intermediary object called a proxy between the work and the collection that tells you that this work belongs to this collection and this collection contains this work. It can also, if it's an ordered collection, assert the orders on the members of the collection. So right now we have, the collection has members. The member resource is this, and with any luck, oh, nope, that's the collection, I'm going the wrong way. With any luck, the members of the collection are my sample. Right now, I think the collection is only shown, I'm looking sort of at Adam. Collection membership is only reflected on the collection level, not on the work level. So again, if you think about changing collection or adding a bunch of things to a collection, I don't necessarily want to have to go update 1,000 objects because I add them to a new collection. I want to create a collection and update the list of 1,000 objects that it contains. That's one of the things that the proxies help us to do. Yeah. I sure hope so. If I delete the work, it should get cleaned up appropriately. We're at the optional section of my list anyway, so we're gonna live dangerously. So we can go look at the work, and I can delete the work. Yes, please. Now my guess is that I'm going to actually still have the work in Fedora, and it's just going to be tombstoned. Yep, so the work is tombstoned. I still have the collection. The collection did not get cleaned up nicely. but the collection itself has no children, so yeah. So the last thing I wanted to do was actually go through and show a slightly different kind of thing. I want to upload a PDF, which is a document, and show the different metadata, a slightly different relation of files, and then we can do anything you want or give some time back. So back to the dashboard. I'm going to create a work. And I keep putting this in the public domain, but I realize that I'm probably actually looking at a translation that somebody probably made, and they might have made it recently enough that it's not actually public domain. So I have to go check. So I've just uploaded a PDF. I've read the deposit agreement. I'm going to let a little processing go on in the background. I'm going to hope it's all already done. Oh, it's not quite done. I don't think it's quite done. Now it's done. So we actually saw it in the middle of, it had attached and created the file object, but it hadn't actually created the derivative yet. So for PDFs, for other Word documents, basically anything that can be opened largely in OpenOffice or StarOffice, I'm not sure what's installed on the back end. LibreOffice. Anything that can be opened by LibreOffice gets counted as a document, and HydraWorks will try and extract the first page, so the first slide, the first sheet, the first page, and create a thumbnail of that. So that's how I'm getting the thumbnail of my document. So this is an image, but if I actually go look at the thing and I ask to download the PDF, I actually get the original PDF not rendered. So again, I have this relationship of having a work Anna Karenina that has a file attachment to it. In this case, because the file attachment has a rendering, I get the rendering. Because I made this institutional when I created the work, the files that I attach, again, by convention, get the same rights that the work do. I could edit the file itself and give the file more or less restrictive access if I wanted to. But the real reason I wanted to look at this was to look at the file and find its Noid 528. So here's my file set object. My file set object in this case has two files. And I found myself wondering, what could they be? So one of them has a text MIME type of plain text. And if I download it, I get a text file. And that text file is actually the raw text of the PDF. So that's something that I think happens at the Hydra derivatives level. That was done quite some time ago. Will allow you to do full text indexing of any of your documents if you want. What he said. So at the HydraWorks, at the Solar processor, it's extracting that text. And then if I go back and look at the second file in that list, this will hopefully be the thing that I expected, which is, again, that PDF. So again, the first time I opened this up and looked at it, I was looking at it through the application. The application was mediating and serving it to me. So all of my access controls, all of my metadata got carried with it. In this case, I'm looking directly in Fedora, and because I have access to my Fedora, I can get at it regardless of the access controls. So this is an interesting case where Hydra is creating two files, hence the file set. One of those files is the originally uploaded file. The other is a derivative of that, which is just the raw text of that file. if I were to take the time to upload a video or an audio file, I would get the same kind of thing, that the original file gets uploaded, and then I'll get a web-friendly playback derivative that gets stored in all likelihood. We're about 10 minutes out from when I should let you go. I have exhausted the official list of things I wanted to show. Happy to answer questions. Happy to have Adam answer questions. There is a proxy between the work and the file sets, again, because I might order file sets, and I might have multiple. I could potentially repurpose, though we probably from a design standpoint discourage it, but I could potentially repurpose the same file on multiple works. And the same file set, so let's look at that. So I'm looking at a file, and the original file, and the thing that I got that from was a file set, and the thing that I got that from was not. Oh, because I went directly to the file set. But if I went and looked at the work, so 767. So if I looked at the work, it has members. The members contains, that's the proxy. The contains is a proxy for. That's the file set object. And then the file set object actually points at the individual files. Yes. Yeah. So I didn't go to the actual file level. So the question was, actually I can just repeat the question. The question was, did I say that you don't share a file set between works? You can, if you so choose, share a file between file sets between maybe Adam's file, not files, but files. So to get into graph notation, most of the conversations I have had strongly encourage your graph to be a tree. So you have a repository, and the repository has collections, and the collections have works. Works might span multiple collections, but from the work level down, it's a lot easier to reason about. It's a lot easier to handle that delete behavior if I know that this file set exists in only one work. You also get versioning issues if you want to start versioning files, which I can start doing. If I version a file in one work, what did I mean to version it in other works? So to Adam's, the PCDM and the Hydra Works model don't actually constrain you to not do that. By convention in the higher level applications, I think we have made the choice, had the opinion that that's a hard thing and presents a lot of complexities that don't deliver enough bang for the buck right now. Linda? So the question is, when I delete something, we showed the tombstone. Is the tombstone just a marker that that ID was used before, or is it more like the old Fedora soft delete where I could actually retrieve the object? And And the answer is that it's just a marker that the ID was used. So you cannot, in a simple way, the question is, can you, once you've deleted the object in Fedora, can you recreate the object? And the answer is not with that URI, not with the same identifier. So I could re-upload that image. I could give it exactly the same title, the same depositor, all of the rest of the same descriptive metadata. But because I have said I am deleting this, the thing associated with this identifier, with this URI, Fedora keeps track of that for some good reasons. You can, again, that's default and conventional behavior. I think you could override that and set your Fedora configurations otherwise, but for our purposes, for most purposes, you really want your delete to be sort of a very serious thing, which is one of the reasons that it asked me, are you sure? So that you can't recreate that ID. So if you're creating external references to that, delete is really pretty significant because you've sort of invalidated that reference. So not quite true, but Sofia will deny me access.
It's for security reasons. So you can't, so somebody can't say, oh, this isn't there. That means I know it's not there. So you do a 403.
Again, behavior that you could change. This is a choice made in the Sofia or the curation concerns level. You could change this behavior, but it's, so I can't just go scan IDs and figure out which ones I don't have access to versus which ones have been deleted. So I'm told, so the question is, there is a thumbnail being generated for that page and for that image, but we're not seeing them in Fedora. Where are they? So that thumbnail, because it is used so frequently, is actually generated and stored, but it's generated and stored in a temp directory in the application server rather than in Fedora, because it's somewhat viewed as being an ephemeral kind of thing. If you ever needed to, you could just regenerate. If that directory were lost, you could regenerate all those thumbnails by just running through. So I'm assuming it's indexed in the Solar document.
Yes, and there's a service that derives it. So if you needed to use it elsewhere in your application, you just call the service. Yeah.
So if you want that thumbnail, the question was, could I find it? It is indexed as part of the Solar document for the object. So there's a service there's a call that you can make to on the object that says, give me the URI or URL for the thumbnail. No, so the question was, are the access versions similarly? It depends. So for that PDF, I'm actually downloading the PDF that is because there's no sensible derivative of it. Similarly for other document types. For the images, it's actually the original image, and we're using a IIIF server to generate all of the various sizing and whatnot. That image was scalable and zoomable and all kinds of nice things. All of that, we're only ever storing the original and using an image server to create all the derivatives to create the panning and zooming. For media files, I think right now the behavior is that if I upload a WAV file, a lower bandwidth MP3 will be created. If I upload a video file, a high def video file, a quarter VGA or low bandwidth WebM and MP4 version will be created and stored in that same place, probably in the same place the temp files are. But again, could be deleted, could be recreated, but the other things, I'm just getting the originals back. Anything else? Otherwise, thank you all. Thank you for your coaching in the first 5 minutes.